Hello everyone, this is Ankit Mittal, your trainer for this training. So we are going to start with the training now. Hi Tawfiq. Hi everyone. So before starting the today's training, let me give you a quick overview about myself and what all things you can expect from this training. Okay, and then we are going to move ahead and have a small introduction around you as well. Okay, so first of all, I'm myself Ankit Mittal, and I am having around like 10 years plus experience uh, in this DevOps related technologies. So I have been working with quite a few organizations now and a lot more projects. So I have worked with the financial products like your wallet. Okay, then there is like payments bank. Then I have worked with the e-commerce industries, digital marketing industries. Then I have worked with some of the mobile, like I have worked on the creation of the like supporting the mobile applications, web applications. Then also I have worked with the IoT based industries, where we were providing real life. There was a hardware sort of product which was used to automate, and then there was many applications like in the real world which we were controlling over our systems that were continuously sending the data and we were reverting back. So it was mostly around the home and the industrial automation that we are talking about. So for creating of these environments, I have worked on like environments which are based in entirely in the public cloud, on private cloud, as well as in the data center. So when I have handled around like more than 5,000 servers in a row, so that we have to like deploy on more than thousands of servers due to the sheer amount of traffic that these environment was receiving. So in order to do that, we have gone through a lot of DevOps practices that we have implemented from the automation perspective to handle such a big environments and to automate the build and deployments, because the versions that we are going to release is much more frequently than the others, so that our customers, our end users are getting the latest features in their application, and the overall productivity was can be increased with our goals that are aligned. So this was the major thing. So we have introduced the build and release processes, monitoring processes, service discovery was there. Then we have also created the containerization on the Kubernetes cluster itself, the which comprised of more than 500 nodes. And then we have also introduced the fully integrated CI/CD, and monitoring was created as a framework where we were using the infrastructure monitoring, the applications monitoring, the mattress monitoring, logging, centralized logging. So all of this was a part of it. Apart from that, there was major whenever we work in any financial based domain, then the major part comes towards the compliance. Okay, so there are different authorities with which you have to make your system compliant from the security perspective, and they are going to perform the audits on your system. So there are different types of audits, like there's your SOX audits, and then there is CISA based in CISA is an organization which hires the external organization to perform the audits for the bank related, and then there are external audits, like even RBI in India is doing their own audits for the financial companies. Okay, so this was just a background of my experience, and the same experience that I have gained over the years, I have compromised this within the training. So I will be sharing with you the most of the training that we are going to perform is towards the hands-on. And we are first of all going to learn about the technology. That will be the initial part. So once we become familiar with any of the tools or the technologies, the use cases, the issues, why this belongs and where does it fits in the DevOps. Okay, so DevOps is already a very big term, and most of the organizations out there have already adopted the DevOps practices, and others are moving towards it. You will see that any of the latest software development technologies like Agile or Lean or any other uh, these type of practices that the organizations are following in order to deliver the overall application. Uh, this closely aligns with the DevOps, and in a sort, they are incomplete without the DevOps practices. Okay, there are lot many solutions which DevOps as a whole provides. So we are going to first discuss about the problems in absence of DevOps up till now, how the things was moving ahead, and then after the introduction of these DevOps practices, what it really solves, what problem does it really solve. This will help you to relate better, and then we are going to come down to the actual solution where how this is implemented, introduced, and how you can automate through that tool. So there are quite a number of tools we are also going to use. Okay, but then the most important part is the overall mindset which you apply in the DevOps, because DevOps is not only about tools, not only about automation. Okay, it's a lot more than that. Okay, so I'm going to cover. This would be the way that we are going to cover the training. First of all, we are going to discuss about the issues, the solutions which DevOps is bringing. Where does the tool fit in the pipeline? And then we are going to move ahead and learn about the different aspects of that tool. And then we are finally going to do the lab sessions. Now, for every topic that we are going to cover within our training would be having a hands-on lab associated with it. For the hands-on lab, we are going to use the Vagrant. Okay, you will have all the requirements itself on your laptop. We don't need any of the external. You don't need any third party, like you don't need any public clouds, private clouds, or your own servers like that. You can perform everything on your laptop through the type 2 virtualization of Vagrant that we are talking about. Okay, but if some of you want to perform the labs on the public clouds or other VMs that you are having access to, so you are completely free to do so. Whatever tools that we are going to learn over here, same can be applied anywhere, in respective of cloud or in respective of your own machines. Okay, so same theme can be applied anywhere. All right, so that was all about me. Okay, uh, so guys, are you able to hear me clearly? Sanjay is saying he is not able to hear. So Subrato says yes. All right, and so the Deepak and other. Okay, then I believe Sanjay is having some issue. Okay, so that was all about me. Okay, and we are quickly going to start shortly with the today's session as well. Okay, now before we start on the today's session, I would like to share you a link. Okay, so everyone is able to see my screen, right? Okay, so I have prepared this Excel sheet. Okay, so I'm going to share a link with you, and you can quickly fill in your experience details. So some of you might be working, some of you might not be. Okay, so quickly share your experience details in this so that I can have a better understanding of about your experience, what overall your profile, and I will going to tweak this training according to your experience level. So if you are having we are having more experienced candidates, then we can go into like somewhat little more advanced topics and in detail. Because but if we are having like less experienced people, then we are going to start from the we will discuss the very basics also. But that's just for the sake, if someone is having any of the issues, you can you can drop me a message in the chat window below. Okay, and I'm going to answer all your queries. So whether that queries is you think of too much technical or not, whether it's just a simple question, don't worry about that. Just raise your doubts. Whatever doubts you will raise, I will answer all these doubts. Okay, and other thing is you might not be able to see all the questions and the what other people are saying, because you can raise a question to the presenter or the organizer. Okay, in that case I'm going to read out the question for you. Okay, and then answer it, so that you have a clear understanding. And the more you raise the question, the more interactive training it would be. And at any point you feel like something is we are going fast, or you need more explanation, you can raise out a question. Okay, I will be happy to answer it again for you. Okay, now I'm going to share you the link in the chat window below. Everyone just fill in your details in this sheet, so that we can have a clear idea about your experience detail. Okay, all right, so I have shared the link in the chat window below. So I would ask everyone to just fill in their details about their profile and their experience and their name in the Excel sheet. Everyone able to edit the sheet? Let me know in case you have some problem. Also, if anyone is having a bigger question and they want to take the mic, I will going to unmute you. Okay, just let me know. I will going to unmute you, raise your doubt. Okay, and then I'm going to mute you again. This is for the reason that there would be a less background noise, so that your training experience would be much better. Also, at the end of the lab, we are going to share you all the material. Okay, as well as the recordings as well. Okay, so you can listen according to your at the later point as well. Okay, all right, so are you guys able to edit? I didn't see anyone facing any issues in editing the sheet. Just start filling this quickly. Hi Janesh, so yeah, you can edit at the same time, Prasad. There won't be any issue. These sheets have been designed like that. Okay, so I see Tofik has already edited it. Okay, uh, you have the link with you. I have shared the link. See, here is the link. Just go to there and start filling it up. So Subrato has done it. I see Tofik, Kanan. All right, everyone, this is for everyone. Kindly take a minute to fill this Excel sheet. Okay, so that I have a better understanding. If you are having less or no experience, that's completely fine. This is just for the understanding of who all is having like the kind of experience you are having. Come on, everyone. Are you able to edit it? Anyone having any difficulties in editing this? I see 33 people are there, only 3 have failed. Uh, no, Bala, there is no requirement for a save button. This is an online Excel sheet, so you don't need to click on the save. It will automatically be saved. Okay. Okay, Pratik, let me share you the link again. Pratik, we are actually starting with our session. So just for the introduction part, I have shared a Excel sheet where you can fill in your experience. So I will have a better understanding about your experience, and then we are going to perform it accordingly. Don't fill in sheet one. Just fill in the sheet two. Okay, everyone, just fill in the sheet two. Don't fill in the sheet one. You have to fill in the sheet two. Okay, I will take care of that. Everyone, you have to sorry, fill in sheet one, sheet two. We can delete this one if required. All right. Okay. So I see now people are filling in sheet two. I think everyone filled in sheet one initially. Okay. All right. So, all right. Good. So we are having an average of 3 years of experience and then up to like 15 years, I see. Okay. That's good. All right. It's good that you are having certain experience into a technical part, although it's not towards the DevOps. That's completely fine because the for the DevOps you don't require any of these kind of initial, like there is no requirement for that up till until you are having some understanding about how the uh, applications actually, like what are the scenario, what is the use case. So it's completely fine if you are having certain understanding about the Linux. That should be an added advantage for you, but it's completely fine. And we don't expect any of the, because we are going to cover everything for you. So all right, so I see some of you are completely new to DevOps. That's completely fine because we are going to cover all the aspects from build and release to monitoring to configuration management. Okay, so don't worry about that. You might have seen certain practices being followed in your organization. Okay, so we are going to cover that as well. So we are going to cover each of the aspect of the DevOps. Okay, All right, so that's good. I see a lot of people like from the different backgrounds are there. Okay, some of you have performed in admins, QA people are there, software development. Okay, consultant. All right, so this is for everyone. Okay, and because you will see that the practices that are being followed into the DevOps actually is integrated with everyone, and everyone gets have should have certain idea about all of these practices being followed in order to improve the overall application delivery and improvise the overall environment. Okay, so let's come back to our training. Okay, so we are going to start with the DevOps now. Okay, so first of all, in today's session we are going to understand why the DevOps is required, what problems does it solve, and what exactly is DevOps. Okay, some of the you would have commonly heard the terms like the DevOps is like all about automation. DevOps is having this huge number of tools which you can improvise. Now this is not exactly the what DevOps is. Okay, DevOps is much more than this. Okay, so we are going to have a deep dive and understand about the DevOps. Once we have a clear understanding about the DevOps, we are able to relate with the objectives of the DevOps. Okay, the practices that comes under the DevOps, and then we are also going towards the end. We are going to see the solutions, that is the different tools, how we can solve the different problems using that, and we are going to go through the practical aspects of these tools, how with some examples, live examples. Okay, but none of these would be in depth till now because this is just an introduction for you. Okay, once we have covered that, then we are going to start with the virtualization. Like tomorrow we can start with the virtualization and the wake ring. That would be the agenda. Okay, all right, thanks everyone for putting your details about the experience into the Excel sheet. So let's start with the DevOps now. Okay, all right, so first thing is let's go some time back. Okay, like something around 10 years back. So I believe everyone would be familiar with this waterfall model. Okay, the waterfall model was the initial model that was being followed to deliver the applications in any of the ID organizations. Okay, so usually what was happening was, if you want to deliver some of your web application software or your mobile applications or anything like that, then you have to adopt this waterfall practices where you are going to perform this requirement gathering from your end users. Okay, and after this all the requirement gathering was being done, then you come down to the system design where you have discussions about how you are going to build your application, what all things you are going to follow, how you are going to create the schemas, how you are going to create your databases, which programming languages you are going to use, which queuing services which you are going to use. Okay, and all of these things. So that comes under the system design. And then was the system implementation, where the developers were actually coding what was initially being laid out and being summarized into the documents. Then these documents was being handed over to the developers for coding perspective so that they can start their coding. Now this would take this huge time from the system design, because the initial requirement gathering and the system design was very rigorous in itself, so it takes months to complete, and then it comes down to the implementation with all these requirements, huge number of requirements for a project. And then this would be like coded by the developers, and once this coding has been done, then it comes down to the testing part. Now the testing team, like the QA team, they are going to perform this testing on the whatever code has been written. So there would be a separate, so there were like two life cycles being followed. One was the application development cycle, and at the similar time there was being system testing cycle. So they are going to write the application, then the QA team is going to write the test cases. They are going to build their own system, how they are going to perform the regression testing on the application and things like that. Okay, now initially, the very little of this was automated from the system testing point of view, and mostly the focus was on testing it manually. So people, there would be like huge QA team would be there that would be going to the browser, testing out the things, and then preparing a checklist whether the things were working or not, and then prepare a report. Now, because that was being done manually, it would take a much longer time to actually test the overall requirements and come out with the problem, and then this report would be sent back to the development team, who is again going to perform all the checks. Now the development team has to be sure that they perform the checks, they actually fix all these bugs and the newer bugs are not introduced. Otherwise, this testing would again take certain period of time before the application gets delivered. Okay. All right, and now it will again go to the testing teams, and once this has been done, it's going to be deployed. Once the QA team passes the testing, okay, it's going to be deployed on the production servers. Now, during the time of deployment, there would be huge issues because you are bringing this huge code base which is having a huge number of dependencies, and if something goes miss, then your application will face downtime, and your application will be having the issues. Okay, and then again certain bugs would be reported, that would be fixed, again would be tested, and then it would be deployed, and then this would be released for the end user. Okay, so you see that the overall system was designed in such a way that it will take significant amount of time at each of the point. Okay, now uh, let's have a discussion around what's happening now. Okay, this was uh, like a history part where what was happening before. This is how the IT industry actually evolved. This was very common and a lot of industries was using it. So let's say take an example of WhatsApp. So I believe everyone would have used this WhatsApp application. Okay, that was a simple messaging application. So the initial idea about the WhatsApp was that it can replace the mobile messaging. Okay, so previously people used to send the messages, but then that was not very interactive, and other thing was it was paid as well, and there was a limited character set which you can send. Then the UI was not interactive and things like that, so WhatsApp came into the picture. Now initially, if you see, the WhatsApp was very limited. Okay, like it was not having all these functionality that it is having today. So there were no groups, there was no video sharing, video calling, no file sharing, no images. So you can't do any of these things. Okay, what you can do is simply text each other. Okay, so you see, WhatsApp in itself was not a complete application at the time it was released. So why it was released? See, what happens is, whosoever releases the bare minimum sort of application into the market initially, he is able to capture the maximum part of the market. Okay, so it's like that, if you are able to release your applications with a certain set of requirements, then you will be gathering the maximum of the market share. Okay, so there would be users who would have already started using your application, although it's just supporting the texting right now, and we all know that everyone did adopt it, right? So WhatsApp did came after with this, and once the users start using the WhatsApp, okay, they will come out with their own feature requests. So now what was happening was that WhatsApp would frequently get updated over few months. Okay, like within the 2 to 3 months they would add certain functionality and then release it to the end users. And this is how we saw that it started creating these groups, sharing of the images, sharing of the files, and lately it introduced the video calling, and then even now you can perform the transaction on the WhatsApps. Okay, so this was done in a way, it was not done, all the requirements was not gathered at the same time, right? So this is was incremental. Okay, over a period of time, these features in the WhatsApp was released, and this actually helped the WhatsApp to actually retain the number of users. Okay, so you see, when there are additional features being released over a period of time, then users get to stick with the application for a longer period of time, and they will adopt those features. And because you are introducing one feature at a time, so the user can make himself aware about that feature, because usually the users takes time to adjust to the additional functionality which your application is now catering to. So you can introduce it over a period of time and expect the users to become familiar with that and start using it. Okay, this also gives you an added advantage that you already have the user base out there which is actually using your application, okay, due to which your business is getting generated, and the it's overall aligned with the company's uh, goal. Okay, and then over a period of time you are continuously releasing the updates, due to which the user is continuously going to update it and then keep on using the additional features. And this is how the users also there is interest of the user in the application to continuously use it. Okay, so we see that this model is quite different from the waterfall model initially. Okay, so in this, not the entire requirement was gathered at the same point in time and all the application was delivered at the same time. No, it was released gradually, and this is how the current applications out there are being delivered. So you will see all the mobile and web application following the same goal. Okay, they are having this huge sprints which are being implemented in a short period of time. Like you can have a weekly sprints or monthly sprints. We are going to what is sprint, how it is being done, we are going to discuss this shortly. Okay, but you will see that these additional functionalities would now be introduced over a period of time, as compared to the previous approach where everything would be just summed up and delivered as a whole. Okay, so yes, Sanjay, we are going to share that model as well. Okay, and the thing is, so this will actually reduce the time to ship the application. So you see, not all the requirements was being delivered at that time. See, if all the requirements you deliver in one go, okay, first of all it will take significant amount of time. If someone would have said to the WhatsApp at that time that gather all these requirements like video sharing, file sharing, image sharing, creating groups, then integrating, opening the in the web as well, and this and that, so this would have actually made it much more complex. Okay, things would not have been that much smoother, and obviously the release date for the DevOps would for the WhatsApp would have already been delayed. Okay, another thing is, when you have this huge amount of requirements, then the code quality also suffers, and there are a lot more bugs into the application, because the sheer amount of bigger scale of the application, there would be more vulnerabilities in your application. So overall system security also, application security also compromise on this. Okay, so you see there is no point in following this traditional waterfall model for releasing the applications. Okay, and another thing is the implementation and the testing. This two parts take significant amount of time in this waterfall model. Okay, now the models that we are going to discuss ahead, okay, the agile, the lean, you will see that they take this and reduce this significantly along with the DevOps practices. Now we are going to discuss about what agile says, what lean says. Okay, those are the another models that companies follows, but those you will see that agile completely integrates with the DevOps for achieving these goals. So if you have to develop in the shortest period of time and release the application, then you have to have all these DevOps practices integrated into your overall model. Then only you are able to release these applications continuously over a shorter period of time. And there are lot many issues when you release it continuously. So there are many issues, like where you have to handle so many builds, and then testing has to be done continuously. Okay, you have to come out with the builds which are working and the reports to be generated, and the at the same time it should be easier for the developers as well. Then only they are going to release it much more frequently with full confidence. Okay, so DevOps fit into all of those goals, and we are going to see how that's implemented. Okay, All right, so let's talk about the DevOps. So, what is DevOps? So, basically, if we talk about the DevOps, usually the DevOps came from a part where it's it was originated due to a requirement that usually the dev and the operations team, these were the two of the traditional teams. They both were working in their own silos. That is, the dev first people would be more concerned about the development perspective of an application. The operations team was more concerned about uh, running of the application. So they wanted that their overall system should run, and there shouldn't be any downtime. So what happened was, there was two contradicting things was happening. First is, the dev guys always wanted that there should be a newer version of application should be released, so that newer features are there, right? For developers, it's all about the features that they are introducing in their application, the newer development that they are doing. And for the operations, they saw that whenever the dev releases this new features, then there would be issues in the overall application, due to which the build would significantly cause certain issues with the system, and their application would suffer, so that they will have to put on much more work to make it work, and then there would be system downtimes as well. So they sort of wanted to avoid that approach. Okay, so you see, there are two contradicting things happening. One, there are dev people who wanted to release the newer features. Okay, then there was ops team which actually oppose it, because the newer features can cause problem and their overall application is going to go down. Okay, or there would be some downtime associated with it if not going down, and that would significantly impact your systems. So another problem was that whenever an issue was reported, okay, the ops people didn't know about the application in much more detail. So they will reach out to the developers. Now developers would again reach out to the ops, saying that this is not their issue, and so ops should handle it. And the ops people will say that it was working before, but after your newer release, the like CPU utilization is going high, or your systems are not stable, or your networking is not stable, packets are dropping, 5x6 errors are there, and so on, right? So there would be a continuous discussion between them or happening over the mail, and this will take a significant amount of time before the issues gets resolved. So what you see, this was causing due to the silos in between the responsibilities of the developers as well as the responsibilities of the operations people who was running that application. Okay, so how do you sort this out? So there was a combination, like the a role was being created. Basically, the DevOps, what DevOps followed was that there should be more collaboration between the developers who are actually responsible for building and of this application. Like, they were the people who were mostly writing this code, right? And then there should be more interaction. They should have more interaction about the with the operations people who are going to create who are going to deploy these applications, going to operate it and maintain it. So without the collaboration between the development team and the operations team, okay, this won't couldn't have this can't be resolved. So there was a combination towards the both, where you actually uh, focus on both the sides, on the development side as well as the operation side. But from the development side, you are not going to actually code. Okay, what you are responsible is for knowing about your application, the different aspects of your application. If something is failing, then what's how your application is going to behave and things like that. So this will help you understand more from the application when the newer releases are going and what issues you can face. Okay, and another thing is, the DevOps helps in defining the flow, like how the development would be done, and how the you are going to scale your operations. So this actually reduce these silos. Okay, DevOps overall goal was to reduce the silos between the development people and the operations, and to combine both of them to actually create a development operations people where they are able to figure the things much more quickly. Okay, they are able to build and scale according to the by understanding the requirements in depth, and they are also going to be involved in the build and release of the application, so that they are having a better understanding about how the applications are going to run on their systems, what all the requirements and things like that. Okay, so this actually help in reducing this silos, and at a point in time you will see that after the once the DevOps has been integrated in an organization, the releases becomes much more frequent. That is, the build and release, the initial silos that was being created is now reduced, and DevOps actually facilitate the build and release part. So you can do much more releases, you can integrate your systems. At the same time, they also create the systems which are uh, much more reliable. Okay, like the we are having certain deployment practices to be followed, like there is blue green deployment, there is rolling deployment. Okay, and then you can change the soft link. So there are certain deployment practices which you can follow to reduce the downtime during the application. Okay, when the applications are getting released, so your systems won't get affected, and if the things are good, then you can make them work. Okay, but if they are bad, then you can automatically roll them back without affecting the production servers. And due to such practices, there is more focus towards the quickly releasing the features. As soon as the developers have written the code, it's possible to release the code into the production environment. So that's what DevOps really focus on. Okay, and to facilitate the faster builds, deployments, maintaining the reliability of the overall application to be delivered as a whole, continuously monitoring it, continuously performing the changes, releasing it, maintaining the scaling it. Okay, the scaling comes from a fact, let's say uh, that you are running in an e-commerce company. Okay, so you plan this sale, this huge sale, and there was a lot of marketing done for it, so you are going to receive huge amount of traffic. Now you have to make sure that your entire application is scalable. Okay, so you have to continuously add the capacity and reduce the capacity when the traffic rises. Okay, so when you add this facility capacity of your infrastructure, okay, that is more number of servers, as scale up the queuing systems, scale up the databases, load balancers, monitoring services. Okay, so if you are able to achieve that, then you have a scalable system. Okay, so previously you will see that most of the system was static in nature. That is, whatever you have created, you have to handle the additional traffic with those systems only. But later on, after the cloud was there, you will see that the resources creation become much more easier, and you can quickly scale out when as the traffic increases. You can detect it, and you can quickly scale out your system so that you can handle the additional capacity of the load that is being generated. You can handle that, and with the additional infrastructure. Okay, and once that has gone away, you can remove the additional infrastructure that you have put into place, so that everything going to work seamlessly for you. Okay, and this increases the reliability of your overall mobile application or the web application that you are working on. Okay, so in short, we see that DevOps is basically a combination of development and operations, where the primary focus is towards the making the releases much more frequently. Okay, to reduce the silos between the development and the teams and the operations teams. DevOps helps to establish the collaboration between the DevOps team and the DevOps or developer team and the operations team. They both work towards the same goal. Okay, and then DevOps can quickly address the issues with the applications. At the same time, they can facilitate the rapid build and deployment of the applications, and they create this through the automation that has been put into place. Okay, so that is what DevOps is. And you will see that to implement this, there is a lot of things from the overall aspect that the DevOps has to make a change in an organization. Even a culture changes comes from the uh, that's an another requirement from for the DevOps that should be there. Okay, so the people should embrace the automation. Okay, the processes that has been put into the place should be to make the work much more easier. Okay, and much more reliable. At the same time, it should reduce the complexity and the barriers to release the code as well as maintain the systems. Okay, it shouldn't be like you have put a process which is actually delaying the things and making it more complex for the development teams to release their code. Okay, so DevOps actually facilitate in that sort of and complements overall goals that we have towards the application delivery. All right, so let's talk about the agile. Okay, so anyone having any questions up till now? So, Pratik, we are going to keep our focus towards mostly on the DevOps part and not only on the app ops or dev in separate. Okay, all right. Uh, let's go through the agile. Okay, so in order to discuss the agile, hi Abhilash. All right. So let's talk about the agile now. Okay. So when we talk about the agile practices, okay, so you will see that in agile, basically there is a sprint planning that has been that happens. Okay. So whenever you have to deliver an application, you are going to create a sprint for it. What is a sprint? Sprint is basically you will figure out what all things that you want to perform during a certain period of time. Let's say a sprint can be of 15 days or 30 days. Okay. Okay, so Abhilash has a question: how long this DevOps will be in the market? So Abhilash, the you will see that DevOps is basically a practices, okay, that is being followed. So the question is not like this: how long will this be in market? It will always be in demand because this is what the companies do. They create these software solutions and deliver it to the businesses who actually use them, right? So it all comes down to this only, right? And there would be the solutions uh, out there which the businesses needs, because they can't really go back to the like old age where they were doing it in books. They need these softwares to work, right? And for delivering of the any of the software, there all the challenges that we discussed initially will always be there. Okay, so DevOps practices would always be there to deliver the better solutions. Only the tools, the underlying tools would get evolved. Okay, so overall practices of DevOps will continuously stay. Okay, but obviously some of the tools and the technologies might differ. That is the thing. Okay. All right. So Sridhar is having a question: is DevOps a one-stop solution for CI/CD? Yeah, Sridhar. So when we talk about the CI/CD, that's an approach towards like continuously integrating your applications and delivering the applications to the end user. Right. So DevOps does facilitate this. Okay. And the overall goal of the DevOps is to make this entire system much more or align with the overall goal. It's not only about the releasing, but releasing in compliance with the what all functions that you are following. Okay, so there can be different things that you want to do, like do the you might having the practices like you want to cover your code quality checks, you want to cover the code coverage part and things like that. So CI/CD external applications might be able to do, might not be able to do, but you can create a custom solution out of it. That's what your focus is. So Janesh is saying, so you mean it's kind of a model to support agile soft develop, and we have certain set of tools to facilitate it. So Janesh, the thing is, whatever model, not only agile, okay, if you are even following the lean software development model, still you need the DevOps practices, okay, to facilitate to work it more reliably, and so that the things are streamlined, that is things are automated. The goals of these software developments method all of these development uh, can only occur when you follow the DevOps practices. Unless and until you don't follow these DevOps practices, you won't be able to implement any of the agile, lean, any of these software development methodologies effectively in your organization. Okay, you will always be lagging behind. Yeah, Vishal, I'm just going to come back to the sprints and how they are followed, and the things what happens in the dev sprints. I just, I was answering the some of the questions, so that's why we came. Uh, so, all right, so let's come back to the agile and discuss about the sprints planning and how they are put into the place. Okay, so you will see that let's say whenever we have to deliver any of the application, then usually there would be a very big application, would there would certainly be some requirements, a lot of requirements, a lot of features would be needed to deliver the overall application. Okay, so for that you can't, you have to decide where you are going to start with, how you are going to implement it. Okay, for that so when if you are following the agile practices, okay, then in that case you will have to create a sprint for it. In sprint you are going to take a certain set of tasks which you are going to perform effectively in your applications. Okay, so whatever that you are going to be performing, let's say in a period of 15 days or 1 month, okay, that you are going to describe in your sprint. Okay, and then you start working on that. Okay, so the goal of the sprint is that you are having a 15 days period in which you have to perform this certain number of tasks, okay, which have been laid down by the business teams, okay, for you to deliver the overall applications. And then there would be a daily scrum. So what is a scrum? uh, Usually there would be different members. See, there would be the different members in your team who all of them would be working on certain sprint. Okay, so uh, whenever so whenever you come, you will have the stand-ups, and that is a scrum meeting would be happening between all the individuals that are working in the sprint. Okay, and then they are going to share like their progress. If they are if they are struck at some place, then there is a person who is responsible for maintaining this scrum, okay, known as scrum master. He is going to go ahead and going to get all of those problems resolved for you. The problems are usually like if you need certain approvals, or there is some blocking from the other team, then he is responsible to get you unblocked. Okay, and at the same time solve all those issues and then move ahead. Okay, and then the sprint reviews would be there. And if some of the see, normally the goal is to finish all the tasks within a definite period of time, and then take on another set of tasks and perform the review, and then make it follow the same cycle. And once all these tasks have been done, okay, then you are able to deliver the module effectively. Once that has been completed, then you are able to deliver a part of it, okay. And this is how the continuously the development occurs. Now if some of the tasks are left behind, then they would be put into the backlog, okay. You are no longer going to work on those tasks again, because that have to be finished into that certain period of time. Now after the other sprints have completed and you have a certain period of time, then you can pick on those backlog tasks and then perform the again, create a sprint around it and finish those tasks off, okay. This is how the in agile the sprint, this is a very top level discussion from the sprint. Obviously it goes into much more details and things like that, okay. But this is to just to give you an understanding about how the sprint actually happens, okay. So you will see that after the review has been done, okay, then again the it goes back to the sprint planning, and then again the sprint review happens, and if something is left after the sprint review, that would be put back to the product backlog. So this is how the agile works and helps in the software development, okay. So Arun Raj, I hope that answers your question as well. So sprint retrospective means that it's again we have performed certain amount of tasks, then we are again going to perform those tasks, and then it's going to go into the planning phase, and then we are again going to perform. See, this is continuously happen. This is not a 1 or 2 weeks or months or 3 months period. It's a continuous approach which happens, and you keep on all the requirements, all the tasks are being divided into the modules, and then you keep releasing these modules into the production, finish those modules. This is how you are going to work, right? And yes, Pratik, I will share with you how the DevOps gets involved in these sprint cycles, okay. But for now, just have an understanding of how the agile works, because this is a software development. Now you will see that whenever these tasks are being implemented, they are basically in the form of a code, okay. So you have to continuously integrate the code, otherwise you can have issues with the integration, okay. uh, but I will share all of those things with you shortly. For now, just focus on the sprint uh, overall agile understanding, how the things work is under the agile, okay. I will make you understand from the technical perspective as well, that how the task gets involved, where the DevOps comes into the picture. But that will come shortly. Just focus on the understanding of agile for now. Okay, so Vishal has a question. What if the high priority story is having some issue and can't make it to the final delivery? Is that kept as a backlog or taken as a hotfix if delivery is ready after the release? Okay, see, it if there is as you have said that this is a high priority, okay, then it's up to the scrum master whether he if there is a release schedule for it, okay, and that's the only thing which is blocking, then you can perform a hotfix. But normally that is avoided unless and until you are in middle of a release. During that time the release has to be done. If it has to be done, then you can apply the hotfix. But normally then it again becomes a priority to resolve those hotfix at the uh, latest sprints. This again your release cycle would be reduced, and then the priority would be to resolve that at the earliest point in time, okay. Now Nikunja has a question like after the sprint review, which will move to the sprint planning and which will move to the product backlog. So Nikunja, if you are having a certain aspects where like if you missed out on some task due to the that were not completed into the sprint, then they are going to move to the backlog. And if you have completed those tasks, then the next set of tasks are you are going to put it under the sprint planning. That would be the next sprint that you are going to implement. Okay. So, Sanjay is having a question. What are the things gets reviewed in sprint review since we discuss everything in daily scrums? So, Sanjay, what happens in daily scrums? You discuss about your progress and if there is some blocking for you. Okay, what all things you have worked on. So these are the like three agendas for the daily scrum that happens. What you have worked on. Okay, what is your overall progress and if there is something that's blocking you. Okay, so this is, you see, this is not a complete picture of overall project or overall the sprint that we are following. This is from an individual point of view. Now at the end, when you have everyone says that towards the end of the sprint, when all the members would have completed their sprint task, then you review the overall sprint from the entirety perspective. Let's say if there were 10 individuals performing different tasks, then you combine them and understand whether the goal was achieved or not. Okay, that is what the sprint review is. Okay, and that's why it becomes important to review everything at the end, and that's how it differs from the daily scrum. Now Deepak has a question. After some constant improvements done by the team, will it lead to a saturation of more changes improvement needed? Okay, so Deepak, usually what happens is whenever we talk about an application, there will always be a set of features that are being required in the application. Okay, so even though you are continuously developing and integrating the newer features, there would always be additional features, and then there are bugs being reported by the QA team and the testing team, and then there is like the external users who are reporting these bugs. Then there's a security team who is reporting the bugs. So there, this would always have, this would won't lead to any saturation. It's like how you are going to align what all things are your priorities, how you are going to build it, and that's all like happens in the sprint. So this is basically organized from that point of view. Saturation is not going to happen like that. Okay, so okay, guys, this is just from for an understanding point of view, like how the applications team work. Okay, but obviously, from the DevOps perspective, you will be having the you are not, we don't actually fit inside the this agile. What DevOps is having their separate practices. Usually you will see that the scrum, this agile kind of scrum stand-ups and sharing the overall progress and things like that, uh, that's basically discussed in the DevOps as well. Okay, but the whether you are running the sprints or not, it depends upon what kind of improvements you are overall gathering. Okay, so you will have certain amount of tasks, and there is an another sort of tracking happens for the DevOps. These kind of agile, this is for the software development only. Okay, and DevOps is not really a part of this. They actually facilitate this. Okay, but they are not directly become a stakeholder into the agile. Okay, these whenever they have to release an end product or they have certain requirements to make the changes, they are going to reach out to the DevOps, and you have to facilitate from the automation perspective that whatever they have written should be integrated, should be deployed, should be monitored, and things should be working. So I will come down to that shortly. Okay. And okay, so Subrata has a question. What is the story point in Agile? So Subrata, usually whenever you are having a bigger change, so you can first of all, if to understand the overall thing, you can create a story. Then there would be the task defined under that story. Okay, to how to achieve that, and then you can divide those tasks into the different sprints to understand how many sprints would be required to implement that story. Okay, and another thing is there is a tool like Jira, which from so that tool really helps you to implement this project management. Okay, like you can create all the tasks over there, then you can create the stories, then you can create those bugs, uh, create the cycles, see the progress, how the all the team members are working. So Jira is a tool for that, and it has been developed by the Atlassian. Okay, just for your understanding how this is being done practically. So that's one of the way to implement this. And then there are other ones as well, like ServiceNow and all, but Jira is the very famous one that I have seen. Okay, Subrata, does that answers your question? Yes, Subrata, so there is an integration. Subrata is having a question. Is it possible to integrate the Jira tool with Git? Yes, Subrata, so Jira, there is an integration for that, right? So whatever changes that you are performing in the Git would reflect back on the branches that you have created and push, that would be reflected back into the task that you are receiving, so that anyone who wants to see the progress on that task can view from those branches. Okay, so you can do that type of integration. All right, uh, let's move ahead. All right, so up till now, we have gone through the agile. Okay, so the now let's talk about the how does the DevOps comes into the picture. So when we talk about the agile, all the development that has been done. Okay, so there are different tasks which the development teams are basically operating. So all this would involve a certain amount of development. Now because there are like 8 to 10 people who are already working, so it's quite possible that some people are using certain variables in their code. Okay, let's say someone assigned a, a a value of 5, and then another person assigned a value of 8. Okay, or it can be an integer or something like that. So it's the chances are that while uh, one was working with certain value, then another person overwritten it in their own code and using the same ones to make it work as a different one. So how do you overcome these issues? Then there might be that one developer has used certain version of the library and another one has used the upgraded version of that library. So which of the library should be put, and whether they are coinciding or not. If there is a conflict between those libraries, then some person would have to actually change their code, because that's a conflicting issue, right? And you can't make both the codes work like that. So how do you resolve these kind of issues? So there for that, there is a continuous integration that is being provided, so that as soon as you have written something, you continuously integrate it. Now another thing is, agile is basically talking about the task to be implemented, right? So when we say about the task to be implemented, it's like the completion of the task should be there, and when they are going to complete, when they are going to be deployed in all the environments. So whenever we talk about from an application perspective, there would be different environments like your dev environment, staging environments, QA environment, user acceptance, and production. Some companies are having the pre-production. So you will see that this helps in overall development of your application. So you will see there is a transition happening, like the development, initially everything is going to be developed inside the development environment, then it's going to move to the QA, from QA to stage to pre-production, and pre-production to production. And this helps in so Pratik, sandbox environments are similar to the uh, like it's helps it has all the requirements for running an application. That is what the sandbox environments provides to you. So as I said, that each company will have certain amount of environments, like whatever I have told you, they will call it something or they can change their name, but the overall goal over here is to test the application, like the lower environments that I talked about, dev, QA, and stage. This is the environments where you are having a certain freedom for the developers to make the changes, okay, in the dev environments. Then the staging environment is more restrictive than the dev environments, uh, so that the QA people are having more control over it. Then if you move to the pre-production environment, that would exactly be same as that of the production environment. And then comes the production environment where you are going to finally deliver everything. This is from the point of view that if you test in the lower environments, then if something breaks, then it doesn't cause the downtime for the users. But if you directly make changes into the production, that would be causing the issue. So whenever these tasks are being performed, then there is a continuous changes required to each of these environments before it's being delivered into the production. So you have to like make sure that all of these changes are being performed, like in the dev to QA to stage, although the production changes are being done in the release cycle. So that would be a separate cycle, but lower other environment should continuously work. Okay, so for that you if you are making all those changes manually, so it will take a considerable amount of time. Okay, and then it would be on the harder side to integrate the same changes into the production exactly in the same way that has been done in the lower environments, right? So you will see that these changes, these things are being addressed by the DevOps. So what they do is the most important priority for the DevOps people is to create deployment pipelines, okay, where the code can continuously be built so that the uh, developers who are working on certain amount of tasks can quickly build on their applications. Okay, and you will see that whenever we initiate a build, that there are dependencies in the form of libraries which have to be downloaded externally. It can be your Maven dependencies or your Node dependencies, it depends. Like these are the basically the libraries which are required to run your overall code, okay, without which it will not work. And because you are doing it frequently, so this should be automated. Otherwise what will happen is significant amount of task would be uh, significant amount of time would be consumed to run it on each server, right? So you are going to do the build and deploy, so that would take us a very huge amount of time. So if you want to do it fast within a limited period of time, then for that effective implementation you need to have the DevOps practices built in your environment. Otherwise you will never going to achieve the goals in any agile implementation. And because it in agile always prefers the changes, so you will have a continuous changes implemented, right? So what agile says is like you can introduce the changes as and when required after the sprint has been covered over. Okay, so if there is a certain set of changes in the requirements, then in the next sprint those are going to be picked, right? And because it's a continuously changing environment, so you need to have a way to deliver all these changes effectively into the systems and then track the overall progress. Okay, and that's what DevOps really provides in for the effective agile implementation. Another thing is DevOps, it also it not only DevOps is not only about the talking about the collaboration, but it also improves it practically from the aspect that development teams are able to build and deploy the application as and when required. how they are going to do it, we are going to use the Jenkins for it. At that time we are going to understand how they can perform it. Okay. And you will see that a lot of automation is being provided by the DevOps to implement this agile practices, so that the task that they are working on, the improvements that they are making, is continuously being built and deployed into the environments. And lastly, you are going to gather all these requirements and deliver into the production as a release. Okay. And another thing is, you will see that because this is a repetitive kind of task, you don't want to waste the human efforts into the same. So you what you want is, it should be repeatable and then automated, so that the build, release, environment setups, triggering of the test cases, creation of the reports, notification of the reports, automated deployments, all of these things are happening multiple times a day, so that if they developers are making some mistake, they can detect it quickly in the environment and fix it, and achieve their task in a certain period of time. Okay. So you see that DevOps facilitates the agile practices, and without the DevOps practices, agile would not be effectively implemented into an organization. Does it make sense? Anyone having any questions still here? I hope that's clear to everyone how the DevOps actually facilitates the agile practices. All right, so let's move ahead. Okay, now there are common misconceptions that about the DevOps. So when we talk about the DevOps, for certain individuals basically characterize the DevOps as in title. Okay. Like it's only a title that can be given to a person and then he becomes a DevOps, like that. No, it doesn't work like that. It's DevOps is not a title. It's also not a separate team. So you just can't just create one of the team out there and say that this is our DevOps team. No, it doesn't work like that. Then it's not a tool. Okay. There is no one tool like which implements the DevOps as a whole. Then it's also not a only culture. So the important part is, culture is a part of DevOps, but it is not only about the culture. Okay. Then it's not only about automation also. Okay. And then it's not an anarchy. Anarchy is like one person or individual or team is having entire uh, you will say that they are having the entire control over the system of how it's going to build and work, right? So it's not an anarchy. Okay. And uh, it's not a one size fit all strategy. Okay. So it's not just one thing, it's a combination of all the things. So what DevOps really comprise is of the core practices. That is, there would be a collaboration, there would be automation, there would be tools for those implementing those effective automation, there would be a culture of adoption of automation as a whole, and collaboration is the most important part of it. Okay. And then how, once you have all of these practices together, then only you can implement the effective DevOps in your organization. So you see, DevOps is basically we are talking about uh, practices inside the DevOps which has to be implemented to complement the software development efforts, and to speed them up, effectively deliver them up, reduce the bugs, reduce the time to deliver the application, make it easier, make it more tracking, effectively monitoring it, then optimizing the processes around it. So everything comes under that part as a DevOps. Okay. So if someone just says that DevOps is this, so no, DevOps is not about this. It's a collaboration, and it's like 4 to 5 things together working to be delivered as in DevOps. Okay. That's what DevOps is. And so Sridhar, as I told you, we are having a detail about that as well. So I will show you. I have grouped them out. What DevOps really is. Okay. Yes, Vishal. So, see, whenever we have any kind of application out there which is dealing with certain every application out there is having certain requirement of the infrastructure dependencies, libraries, and all of those things. So you can effectively use the DevOps practices to manage those applications and to add the additional value inside those applications from the overall perspective. That's what DevOps is. Okay. All right, so let's talk about some of the how the things actually evolved overall. Okay, so you will see that initially, let's talk about the development process, because right now we have been dealing with the application. So let's talk about the development process here. So initially, you will see the waterfall model was into the picture. Okay, that's what being followed by the by the IT companies to develop the applications. Now that waterfall model would eventually be replaced by the agile, due to the fact that agile promotes more changes in a controlled way, and you are able to achieve the better results using the agile. Okay, so it waterfall model would be replaced by agile, and for agile, you DevOps is going to complement the agile. Okay, so if you want to implement the effective agile, then you will have to implement the DevOps practices as well. Okay, then comes your application architecture. Now, when we talk about the application architecture, this is the most important one. Okay, so you will see that initially the monolithic kind of applications was being developed, which runs in a uh, single environment. Okay, and later on you will see that the multiple tiers was being introduced into the monolithic, so that they worked across the multiple servers, but overall application as a whole would be provided as a single bundle. So what was happening was, let's take an example of an e-commerce company only. So you will see that for an e-commerce there are different modules. Okay, so there is like a catalog. What is a catalog? Catalog basically displays all the product offerings. So whatever the company is selling, everything, all the services would be shown over in the catalog, all the products. So if you visit any of the uh, like Amazon site, so you will see all the products that amazon.in or amazon.com is selling. Okay, that is being displayed inside their catalog. That's what catalog is. Then once you have decided what product you want to buy, you add it inside the cart. Okay, so that is what the cart is. Once you have decided what you want to buy, you can add inside your cart. Then there is a service known as promotions. So promotions, what are promotions? Basically, there is a code through which these e-commerce companies can provide you with a certain discount. So those are the promotion services. Once you have placed the order, there would be logistics involved in it to deliver the overall product to you. Then there is a notification service to send out emails, text messages, and things like that. And then there are many other services as well. Okay, why I am telling you is, like, let's talk about these five services. That is catalog, cart, okay, notifications, promos, and logistics. So you see, there are these are the five important services. Now, initially when we talk about the monolithic kind of applications, all these five components would be created as a single system. That is, as a overall system would be designed so that all of them are working together. There is no isolation between them. They are delivered as a one application only. So all the code would reside inside one repository, and everything would be on the single system only. Okay, so this is what the monoliths architecture was about, and due to which this monolithic architecture faces the significant issues. Now, what were the issues in this? Let's say tomorrow, after the initial application the company developed, it has grown so big. Let's talk about Amazon only. So Amazon is able to handle millions of orders. Now just think, like, if they would have developed the monolithic kind of architecture and they were running some sale, then huge number of people are going to come to there uh, web application or their mobile application. Okay, so in that case, the catalog which is displaying all these products would be effectively receiving all these traffic, but the notification or the cart or the logistic might not be receiving that much amount of traffic as much as the catalog is receiving. This is from the point that there would always be lesser number of orders as compared to the people who are visiting to view the items, right? So now, although it could be on the higher side, but it would never be as much as the, like, all the people who are visiting the web application or mobile application of Amazon is not going to buy something, right? Some of them are just visiting there. So what happens is, if we have to scale the catalog only, it's not possible, because overall application has been written as a whole. So what was happening was that you have, if you want to scale for higher traffic, then you will have to scale out entire code base. So your cart is going to be scaled, your notifications is going to be scaled, everything you are going to add, all the so for all the applications. Okay, this is how the monolithic was working. Another issue was that if let's say a catalog team was working on their code and they made a change in their code, okay, which was having some issue, and the code was not running, some library got missed, okay, during the deployment. So you will see the entire system is going down, because everything works in on a as a whole, as a single thing, right? So it's basically a monolithic application. So if one of the part is bad, then entire application goes down. Okay, so it was very difficult to scale and very difficult to maintain. Okay, then there was no focused area, no separate teams to scale out individual components if they grow very big. Okay, so these were all the limitations of the monolith. So what happened was, the microservices kind of architecture was evolved. In microservices, you will see that all the components that we talked about right now are being delivered as a separate service. What this mean is that, uh, whether it's cart, whether it's catalog, whether it's notification or logistic, each will be working as a separate service. Okay, when I say separate service, it's entirely independent of the other service. Like cart will only be having the operations of the handling the operations of the cart. It doesn't really worry about the catalog or what the logistics is doing. And then the so we were able to divide the product that the company was offering into the different modules. Okay, like cart, catalog, separate teams were there. Okay, and they were maintaining their own application. Okay, and so what are the advantages of microservices? So first advantage is that, let's say if the notification team is working and they are having some issue in their application. Okay, and so, so at this point their system goes down, because they were having a bug in their application which they didn't resolve. This was causing a library issue that was making their code not work right. So let's say notification service goes down, so what happens? The overall application will keep on working. So you will see the catalog, that is the end users will see that the catalog is still working, cart is still working, they are still able to place the order, get the deliveries. Only they are not getting the SMS or email when they place an order. Okay, so that's a responsibility for the notification team to resolve this. Okay, so they can resolve it individually and your application is not going down. Okay, but in a monolithic architecture this would have gone down. Okay, another thing is, if tomorrow, let's say, there is some sale and catalog is receiving this huge traffic, then only you can scale the catalog servers. Okay, so you can add the additional capacity for the catalog only, you don't need to scale the other applications which are working just fine. Okay, So it depends upon you how much you want to scale, but entirely you don't have to scale each component significantly. Okay, that are the advantages of the microservices. So I hope this is clear to everyone, a difference between the monolithic and the microservices kind of architecture. All right, so next comes your deployment. Okay, so let's talk about how the deployments got changed over a period of time. Okay, we are not going to cover the entire details of this right now, because we are having each being covered as a separate topic. Okay, in the training, then we are going to discuss in depth about this, but for now we are just going to have a introduction about what how the deployment change over a period of time. So initially you will see that there were physical servers. So what are the physical servers? So usually you would see that there are this huge servers which comes with this huge set of resources. Like you can have a physical server which is having a 32 cores CPU cores and 120 GB RAM in them. Okay, and then you can run any of the web applications or things like that. So initially what was happening was that you will create a physical servers in your data center. Okay, and then deploy the applications directly over these physical servers. So what was the issue? uh, See, the issue comes from the fact that you are having so much resources. Okay, 32 core CPUs and 120 GB of RAM, which is very expensive. First thing is it's very expensive to have such a big physical server. But the point of view that you are only able to run one application on this server, you know, has a significant issue. That is, our application might not be so big that we have to use so much of resources. And then from the high availability perspective, at least two physical servers should be there. So just think, like if we are working in a microservices kind of architecture and we are having 200 microservices, then we at least should have 400 physical servers like that, and that would be significantly drain on the overall resources and might not deliver the good results. So this physical servers required a lot of hardware to scale, and then there was not no scaling in the behind. Like if the traffic this physical servers take huge amount of time to be built. So you will have to plug in the different hardware devices. Once you put the additional RAM in the RAM slots, and once the physical architecture has been created, you will install the networking, then you will install the operating system, bootstrap the operating system. Once the operating system has been installed, then you are going to configure the networking into it. Then once the networking has been configured, then you will install the uh, code on it, your application like Nginx, Tomcat, things like that on that server, then deploy the code, and then your physical servers becomes ready for running the application, right? So this requires a lot of time. Not much of the automation was there, a lot of hardware was required, it was very expensive, not scalable, and lot of administration task was there to maintain the physical server. And then the application was don't require so much resources, so it was basically a wastage of the resources as well, physical servers. Okay, so what was the solution to this? Because our application doesn't require this much resources, so it makes sense that we divide such a big server into the smaller number of virtual servers. So what we can do is, if we are having 32 core and 120 GB hard disk, then we can divide them. Let's say we just want to run 2 core and 4 GB RAM, so we can divide it accordingly. So you will have at least 20 or 30 servers, okay, with you, and you can run those on those physical server. You can run it like a virtual server. So you will create a virtual machine out of it, which will have a limited set of RAM and memory available with you. Okay, and then instead of having one server, you are having 30 servers right now. So we can run 30 different application on those virtual machines. So that makes sense, right? To divide them between the different virtual machines. So you will see that after the physical servers was there, then the virtual servers came into picture, and we used to divide the physical server into the smaller virtual machines and then run the code on this virtual machines. So applications would run on these virtual machines. Okay. After the virtual machines, you will see the containers were there. Okay. Now what does the containers do? So see, container is just a package. Okay, so it's a runtime basically, which is having all the dependencies that your application requires to run. Okay, so it's not necessarily going to have all the operating system dependencies. It is going to have all the dependencies which is required to run your applications. Okay, so you can ship, like you can put any whatever dependencies is there to run your application, you can bundle it inside this container, and then you can run this container anywhere, whether it's your physical server, whether it's your virtual server, whether it's your cloud, whether it's your laptop. Okay, you can just run that container and your application would be running inside that container. So it's kind of a packaging. Okay, so you can package your entire application inside that container and then deploy that container anywhere, and your application will work on it. Okay, so nowadays containers are being used to deploy the application as a whole. We are going to discuss about this in lot more detail. We are covering the Docker containers in the training, then we are covering the Docker Swarm and the Kubernetes. So at that time, we are going to cover much more detail of what exactly the container is, how virtualization is implemented, why it's gaining so much weightage now. But for now, just understand that if you have to run an application, package everything inside this container, okay, and deploy this container. And then once this containers comes up and running, then your application would also come up and running. So you don't have to run the build deployments, things like that. Okay, you just need to create everything inside the container, deploy the container, and that's it. It's going to run your application. Okay, so I hope this all these three are clear to everyone: physical servers, virtual servers, and the containers. So Arun Raj has a question: what is the difference between a virtual machine and cloud? Okay, so Arun Raj, first thing is like the difference comes from the fact that usually when we talk about the virtual machines, we were handling the hardware part of the virtual machine. Okay, so companies would set up their own data centers, then would create the virtual machines for themselves and then use them. The downside was that they have to maintain their own data center, and then the virtual machines that they were creating, it would not scale out. Okay, uh, easily, as and when demanded. Okay, and they would have to write all these automation for themselves. Okay, now when we talk about the cloud, in cloud, what's happening was, first of all, the physical servers and all the data center operations was being managed by some external cloud provider out there. Then they will have their own virtualization software implemented on these virtual machines to create these virtual machines, and that would be provided in the form of a web application to you, so you can access all these virtual machines over the web, like in the browser. Okay, and then they have created the APIs for managing these virtual machines, so you can call those APIs to create the virtual machine and create it on demand. On demand means you can create when you require and destroy it when you require. They are only going to charge you for the virtual machine that you have created and how much time you are running. So let's say we created the virtual machine only for 1 hour. Okay, so they are only going to charge you for that 1 hour. You don't have to pay the entire fees of that physical server. You are just using for 1 hour, pay few cents and destroy the virtual machine. That's it. Okay, so it works on a shared revenue. That is, there are large number of users out there who are going to use the resources. So you might require only 1 hour, then there might be like 100 people who require for 1 hour each. Okay, so it combines and forms 100 hours, right? And the company gets billing for 100 hours, like that. Okay, Arunraj, does that answers your question? Difference between a virtual machine and the cloud. Now, it's important to understand that even the cloud is running the virtual machines only. That's also a virtual machine. Okay, but it's a SaaS based service, that is a software as a service, which is run by some external vendor, managed by some external vendor. They are having entire infrastructure setup. They are maintaining networking, security, everything, and providing to you. That's why we are referring to it as a cloud. Okay, and they are having this huge capacity to be built, right? So that's why we refer to it as a cloud. So Nikunja, the difference between the n-tier and microservices is that usually what was happening was, if you have to run a monolithic application on scale, then you will create the different nodes. Okay, I mean different servers, and deploy your entire code on that, and then each of those server would work as an application as a whole. Okay, because it's a single package of application. That's the main issue. You understand that you can deploy a single package on multiple machines, but still at the end of the day it remains a single package, so it will scale out everything when we just don't want to scale out everything. That's what n-tier is. N-tier means server, and means you can have as many servers as you like. Okay, but that's not practically true, because your database comes into picture, and that's having a limitation of how many connections you can open on a database. Theoretically you can have as many servers as you like. Practically, a number of connections in your database that you can open, you can have as many as connections as there, which allows you can have as many machines as there, right? So that's a difference between the n-tier and the monolithic. Okay, but sorry, n-tier and the microservice. So n-tier basically runs the monolithic applications on different servers. Okay, I hope that answers your question. All right, and lastly, let's come down to the application infrastructure. So when we talk about the application infrastructure, there is a data center. So we already talked about the data center, how the companies used to create their own data center, their own servers to run the application. Then came the hosted providers. Who were the hosted providers? So you would have seen that there are external hosted providers which were providing you cPanel type of services, where you can create your applications, like deploy the CMS and all from those hosted environments. And what they will do is they will provide you with a mechanism, usually uh, these cPanels, through which you can deploy some PHP kind of application, or Java kind of application, and then run inside their servers. Okay, they will host it for you. And finally came the cloud. Now hosted environments only provided you with some with the end application, like the cPanel, through which you can run the application in a limited set of quantity. So they will assign you certain disk space, a shared server on which you can run your application. Then you can buy your separate server and the amount of disk which your application needs. Okay, and they will host the application for you. So that was the hosted solution, but it was not very scalable. So tomorrow, if you started gaining the traffic, then these hosted uh, uh, providers will charge you very heavily for maintaining your applications on scale. Okay, so you will see that these hosted external providers were being replaced by the cloud, where everything was over the web. So you can create your own servers, your own load balancers. Everything which is required to run your application would be provided by these cloud providers. Okay, and then you can directly run your application in the cloud itself. Okay, that's what the application that's how the application infrastructure evolved over a period of time. All right, so let's talk about the DevOps goals. What are the DevOps goals? See, when we talk about the goals for the DevOps, the first and the important part is the frequent releases. Now, when we do frequent releases, okay, obviously the code base won't be that big. Okay, you will have a smaller code base which would be released more frequently. Now, what are the advantages of this? So just think of a condition. Let's say you were writing an application which is having 10,000 lines of code, and just uh, think from the fact that because you were just writing it down and not you didn't verify whether it will run on in the production type of environment or not. You were just coding it in your environment, okay, where nothing else was there, and you were keep on coding, right? And things work very good for you. You thought that it will work in the production as well, but when you go into the production, there is already a large amount of code which is already running. There are other people who are continuously writing their own code, and then you have to merge that code. So just think, when you merge, so your code stopped working on, let's say, line 100. Then you have 10,000 lines of code, but it's not working on the 100th line, so nothing is going to be executed further. Okay, so you see, it's a very significant issue. Now the chances are that you fix it, and then 120th line is having issue, then 150th. So how much code you are going to fix? Okay, so it becomes an issue. So instead of doing the big releases of like 10,000 lines of code, what you can do is you can just release 100 lines of code at a time, or even smaller. So this is just an idea. Obviously this is not about the lines of code, rather the modules of code that you are writing. So the application is divided into the modules, so you can release much more frequently, so you are sure that your code is actually working. So this is from the, so that's why you will see that the frequent releases resolves these kind of issues. Okay, that is the integration issues would be resolved. The shorter requirements would be there, so you are going to fulfill them and make it work in the production. If let's say you have just written the 100 lines of code and it is having an issue, then you will be able to quickly resolve it. Okay, if you are facing this, let's say on 10th line, 20th line, so you would be able to resolve it. But obviously a bigger application and so many modules would make it more difficult to release. Okay, so that's the primary goal. So you are going to do the frequent releases. So you will promote this culture where the developers, whatever they have written, as soon as they have written, they are going to release it. So you will have smaller releases, that is lesser code would be there, but there would be more frequent releases in your environment, and that will make everything working. Okay, so that you don't have to rewrite and waste so much time in rewriting it again. Another thing is it reduces the efforts and risk. So you see, it he don't has to take a risk of writing the code entirely again, and it also reduces the efforts, right? So and that's why it reduces the efforts and risk in your environment. Then it reduces the cost of product iterations and delays. So normally what was happening was, whenever you have to create the product, then there is a requirement that there might be different products which your organization is working, and then you have to do the same. You can use the repeatable code, but then doing this iteration again into the different environments is causing the issue. Okay, and which is actually delaying your overall code delivery. So because these environments are there, like the dev environment, staging environment, pre-production. Okay, so you have to do this product iteration. The product iteration means building the product from the scratch. Now whenever, for each release, before going to the release, you will have to build it in on the all the environments, and that will take a significant amount of time that can cause the delay in the overall release of into the production. Okay, because you are first going to test in these environments. If that's not automated, then it will take a lot of time. Okay, so uh, and it will also increase the like the time to which you release your application. Okay, so the main goal is to reduce this product iterations in the different environments that we are having, and reduce the delays in the production releases of your application. Then comes DevOps basically promotes a culture of communication and collaboration between the developer and the ops team. So you will constantly communicate and understand overall requirements, do the build and releases there. So whatever issues the development teams are facing, they are going to reach out to you, and you will closely collaborate with them to resolve these issues. And there would be a consistency and the speed through the automation. So when we talk, although we are doing a frequent releases, but because we are integrating everything inside the production, so there would be a consistency being maintained. Even though you are doing it repeatable changes, still the consistency would be maintained, and the speed would be attained through the automation. Okay, so you are going to test everything in the lower environments and then deploy in the production environment, but everything is automated, so it would be done fast and you attain a considerable amount of speed. Okay, so these are the overall goals of the DevOps, how you can implement what the DevOps really aspire in an organization to achieve. Okay. Guys, just a second. Okay, let's take a break here for 10 minutes. I'm going to put a timer. Okay, let's take a break here for 10 minutes, and once we are back, then we will start back. Okay, I will be on mute at this time. Okay. All right, everyone. So everyone back now? Okay, I see a couple of questions. So Janesh is asking, once you are back from the break, I just wanted to know how will we do the practical hands-on? Yes. So Janesh, we are going to use the Vagrant. Okay. That will allow you to create the virtual machines on your laptop itself. Okay, and we are going to I'm going to let you know what configurations do we need for the virtual machines, and then you can create the virtual machines using the Vagrant. First lab session, I will show you how to create those virtual machines, and then for all the topics that we are going to cover, we are going to create the virtual machines and do the lab sessions on them. Okay, but before we reach out to that point, just have the understanding. Okay, so that you make yourself familiar with the virtualizations, because we are also having a topic on that and the Vagrant itself. So we are going to quickly cover the theory part of it and then perform the labs for it. Okay, and everyone, I would just suggest you to focus on the theory as well, because during the lab sessions I'm going to use the terms that we actually cover in the theory part. Okay, and then you should be familiar with those terms, then only it will make sense to you what we are doing inside the lab. Otherwise you won't be able to relate with the lab. Okay, and don't worry, we are having the lab sessions for all the topics. Just this initial introduction part is not having the lab. Rest all the topics are having the labs associated with it. Okay, so everything would be on the practical wise. Okay, all right. Gopi is having an issue. Can you please share the document? Gopi, you will be receiving this document and all the further documents into your LMS portal. Okay, from the Cognitia team, you can request an access to the uh, learnings portal, that is your LMS portal. You will have all the recordings, documentation, everything which we do, okay, would be there for you. So you can easily refer to this document over there. Okay. All right. So Soham is having a question. Ankit, you had given some links in the beginning of this session. Can you share that again? I joined late, so couldn't find it in the chat. So Soham, we only shared a link for the that Excel sheet. Okay, that we gather the experience of all the people who have joined into the training. Okay, uh, rest, as I told you, you will find all the documents, everything inside the LMS portal. Okay, for this training as well as all the future trainings that we are going to do. So you can have we will provide you everything inside that only. Okay, no separate links are there. I will share you some of the links when we are doing the labs, from where you can download the tool, and for that, so I will share that during the lab session, so don't worry about that. Anyone else having any questions? All right, so let's continue on the training. Okay, so let's talk about the characteristics of the DevOps. So, what are the characteristics of the DevOps? When we talk about the DevOps, it's about the characteristics of DevOps. It basically treats the infrastructure as a code. So, okay, so Unkar has a question. These lab sessions are going to be a web-based session, or do we need to download any application for that? As I am using Office machine, I may not be able to add any application on that. Uh, yes. So Onkar, the lab sessions that we are performing, okay, uh, these requires the virtual machines, okay, and so normally what we do is we allow you can we expect everyone to be having a laptop available with them. Okay, so you can create virtual machines on them, but if you are having your office machine, so you can't create an virtual machine on that, then you can use the some virtual machine from the cloud providers like AWS. Okay, although that's not a part of it. Okay, uh, like how to create those virtual machines and all, but it's pretty much straightforward. Okay, so you can perform the labs there as well. Okay, but I would certainly suggest everyone to use their own VMs, because the way that we are going to create the virtual machines is all automated. You will be just running one command and your virtual machine will come up. That's that much simple. Okay, so you can create as many virtual machines as you like, and you don't have to pay anything extra. You don't have to worry about the licenses. You don't have to worry about anything. Okay, so it's up to you, Omkar, how you get this. I believe you can get into with the support as well. They might be able to provide you the some of the virtual machines as well, but I will suggest you to create the virtual machines, for practicing. All right, let's talk about the characteristics of the DevOps. Now, when we talk about the characteristics of the DevOps, first thing is the DevOps basically treat the infrastructure, that is your virtual machines overall environment, as a code. So what why it treats everything as a code? See, whenever you are making some change on any of anywhere, okay, in your application, let's say you are changing some Nginx configuration. So if there is some issue in the infrastructure, okay, and if it has been written as a code, then you can quickly, first of all, you can scale the entire infrastructure as and when required. So you can create the exact replica of your infrastructure, like in public clouds, your private data centers, or anywhere, right? Another thing is, if something breaks in your infrastructure, then you can revert back to the older version. So that we are going to discuss in more detail, how we can version the infrastructure. But the thing is, because everything is written as a code, okay, so you can quickly fall back to the previous version, and it will automatically fix your code, fix your infrastructure overall. Okay, how that is being done practically, we are going to discuss around that. For that, we are having 4 configuration management tools basically in the training. That is your Puppet, Chef, Ansible, and Salt, which helps you to convert your infrastructure into the code practices. Okay, that we are going to learn. The details of and the practical implementation we are going to learn when we come down to that tool. Okay, next is it helps to build and deploy the applications faster and have the feedback cycles available on each of the cycle. So I will show you one of the diagram for the DevOps, where you will see that each module or each stage in the DevOps basically act as a feedback for the another stage. That is, if you are doing a deployment, the deployment will gather all its detail from the build. Okay, first of all, a build cycle would be there, then a deployment cycle would be there. After deployment, testing would be there, and sorry, after build there would be testing, and then after testing there would be deployment. Okay, like that. So there would be continuous feedback cycle, so each, and it will be a closed loop. So what will happen is, this cycle will get repeated again and again to improve the overall application delivery. Okay, so it's a characteristic of the DevOps. This will become more clear to you shortly when I show you the that diagram. Okay, and then you will see that these feedback cycles that we talk about are achieved through the continuous delivery pipeline. So what is a continuous delivery pipeline? It's basically the different stages of the pipeline which you have to achieve in order to deploy your application into the production servers. Okay, uh, now we are going to cover the pipelines as a whole. So I'm going to show you the example as well as the lab of how you can create those pipelines. There are 2 types of pipeline. Okay, we are going to cover both the pipelines when we do the lab session for Jenkins. Okay, and uh, so these pipelines would obviously be automated so that you can easily create them on demand, and while the developers are doing production deployment, they can create it on demand. Okay. And usually these pipelines are like human free, so you don't have to do any of the manual changes into them. Okay. They are entirely automated, so you don't have to make any of the changes into them manually. And you will see that in there will be the logging and traceability, so you can gather all these logs and send it to a centralized system for the logging solution, where you can analyze the logs from all these systems. So you will see that when we talk about the characteristics of DevOps, first of all, the entire infrastructure, everything within the DevOps perspective work as in code, so that we can easily version it, we can easily reproduce the infrastructure as and when needed, we are easily able to build and release our application. Then all the stages of the build and release are provided in the form of a pipeline. That pipeline is having all the stages in an automated way, which is like human intervention free. All the stages would be independent and would be having their own logging and everything implemented. And this pipeline would deliver the application into the production environments, and then the monitoring would also come into the picture. Okay. So this is the overall characteristics of the DevOps as a whole. So initially we discussed a slide where we talked about what DevOps is not, and here is a slide to show what the DevOps is. So it shows you the DevOps values. So it all starts with the culture. Okay. Culture of an organization is important to embrace the automation and to seamlessly migrate from one environment to the next environment through automation. Okay. So after culture comes your automation. So you will have to create that automation so that there is seamless migration from one stage to another, like from dev to stage to prod, like that. Okay. Then after automation, you have to follow the lean methodology. Now, what is the lean? See, lean basically focus on the minimalistic amount of requirements that is being required, so that you don't have to waste on the resources. Okay. We are going to discuss about the lean in more in the coming slides, but there it will become clear to you to achieve the overall goal in the minimalistic amount, so that we don't create the additional and cause the wastage of the resources. Okay. Next comes your lean, then comes your measurement. So whatever changes that you are bringing, whatever automation that you are bringing, whatever advantages that it's going to bring it with it. So let's say you say that I'm creating a pipeline. Okay. That will help me to move from one stage to another much more quickly, from staging to production much more quickly. So how much time it took to move from the build to testing, and how much time it took from testing to deployment. Okay, like that. So you have to measure each and every stage, how much, and then gather an understanding whether you are actually improving the overall processes or not. So measurement is an important aspect of the DevOps values. So you have to measure the data, that the value that you are bringing with the DevOps implementation is actually being there. And then lastly is the sharing. So you should have a sharing culture, and it should be between your team members, between your developers and the operations people, between the overall, so to effectively manage. Okay. So these are the fundamental core values of the DevOps to effectively implement DevOps in any organization. Okay. So this is what DevOps is. Now, who are the stakeholders for DevOps? See, on the dev side, there are architects, business representatives, customers, product managers, project managers, quality like QA and QC, and the supplier. These are the stakeholders for the uh, DevOps. Okay, these will be the people who are going to get affected from the dev side. And then there are system engineers, system administrators, information security individuals, IT operation engineers, release engineers, database administrators, network engineers, and suppliers. So these will be on the off side. So all of these people would be getting affected like one or the another way from the DevOps practices, and all of them would have certain advantages after the DevOps practices comes into the picture. Okay. Okay. So the question comes, why the IT and businesses are driving the DevOps? Okay. So you will see that when we talk about any of the businesses out there nowadays, whether it's logistics, whether it's marketing, whether uh, 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 any of the like even the different industries, you will see every of the business is actually becoming a tech business. Okay. When I say a tech business, you would have heard about the office spaces which is being shared, right? So you can set up your own offices. They are also embracing this technology to and shift their focus towards being a tech business, which is the technology is enabling these businesses to reach out to larger user base and provide more insights into the business operations and track the overall user feedbacks, improvise on their operations and things like that. So you will see that all of these businesses are moving towards the tech business. And then there is IoT. See, IoT actually transforms your it reduces the gap between your digital and the real world. So you can have something like the machines which are working for automation of your infrastructure in real. Okay, so you have some home automation, industries with automation. So IoT practices helps you to achieve that. Okay, uh, that is also increasing. So we see that this will significantly move the businesses closer to the tech side. And whenever we talk about any of the tech side, then obviously the DevOps practices would come into picture. So you would see that DevOps is required across all the domains out there. So whether it's your banking industry, whether it's your marketing industry, whether it's some logistics industry or financial industry, so any of the businesses out there would all require this DevOps practices to be implemented. Okay. And uh, uh, usually if you see towards the customer, they only values the outcomes and not the product. So for a customer, it always is like the features that they are using, the reliability of the application, whether the things are delivering what it should have been in the shortest period of time. For that customer, these values is always is much of more concern than as compared to the products. Okay. And then there is like a lot of digging inside the data to provide the values out of it. So huge number of systems and automation is required for that as well. So that's also driving the DevOps. Okay. And obviously for every company, there is a customer delight is more important uh, than the customer satisfaction. Okay. So you will see that all of these factors are contributing towards, and businesses as a whole is driving the DevOps. And that's why these DevOps practices are okay. For Sanjay, IoT basically means Internet of Things. Okay, so you can have things your in your real world, which is closely mapped with the ID systems. Uh, so there are numerous IoT examples like your home automation. That's very common. So you can have all the aspects of your home integrated with the different controllers that would continuously send the data to your applications where they will monitor. Let's say there is a thermostat, and if its temperature increases beyond a certain value, then the cooling would be increased further. So it will automatically provide you seamless experience. Okay. Now this is particularly of useful in the data centers as well, where a lot of heat is being generated by the server. So if you are continuously feeding the temperature to your IT systems and they are continuously recording it, so you can set up a triggers in your application where the thermostat temperature can automatically be lowered by your applications if the heating increases beyond a particular level. Now this is also important in the blood banks as well. So the companies which are responsible for transferring of the blood from one place to another, it only works at a particular temperature. If it goes down that, then it it's kind of it's basically of no use. Okay, so IoT plays a significant role. It can monitor continuously and raise the alarms, as well as take certain actions as well. That's what IoT implements. So you see that sends out huge amount of data, huge amount of huge applications would be there, backend infrastructure would be there that has to be handled. Then all of the practices would have to be followed over there as well. And the changes in the IT systems would be affecting the real world. Okay, so just think like in the home automation, if your gate is sensing that after you bring in the car, your gate should open. If it's not opening, then it's affecting your real world, right? So that kind of automation we are talking about, that's IoT is increasing. That's why the businesses are adopting these DevOps practices to move ahead. All right. So uh, what are the benefits of DevOps? So whenever we talk about the DevOps, it's basically creating a sustainable infrastructure, like it creating a sustainable business model for everyone to work. It's continuously adding the questions of the and continuously helping the businesses to innovate further and to collaborate between the different team members. It's reducing the repeatable kind of steps which was being done manually. It's kind of automating it, so the repeatable, it's making the overall applications repeatable. That is it can be transferred from one environment to the next, so it's a repeatable process, right? And then it's also increasing the reliability and the predictability of an application as well. So reliability comes from the fact that you are able to handle the deployments without causing the significant downtime, and then you are also being predictable how much time it will take for your overall releases from lower environments to the higher environments automatically. Okay, so it's a predictable kind of approach where you already know this much amount of time would be required to release the newer version. And it also helps you track the faster reaction because you are able to quickly deliver the application. So businesses came to know whether the thing is working or not, and they can do more testing, like they can test different models to achieve the most significant way, because the things are implemented much more quickly now. It also helps in the higher return on the investment in software. So whatever they are investing in the IT, they are getting the higher returns because the overall process has become much more streamlined and fast now. And DevOps principles would always be implemented to all the kind of businesses out there, as I just told you, because a lot of close interaction between the businesses and the IoT is there, right? So it's also driving a lot of businesses to move towards the uh, infrastructure, like information technology practices. Okay. All right. So those were the benefits of DevOps. So like if you will take this example of amazon.com, they are having this microservices kind of architecture. So you will see that they are having this huge number of deployments which are being facilitated by the DevOps, and they are doing deployments in every single hour. So 1079 deployments every single hour is being done in the amazon.com. That's a huge amount of deployment if you consider from the fact that initially people used to do it over one deployment over 15 days or 30 days, right? So this much deployments per hour, so it can only be facilitated by the DevOps practices. And you will see that this is a mean number of hosts. So you see how much big infrastructure is there. There are like mean number of hosts is coming out to be 10,000. So you will have to deploy your application on 10,000 servers simultaneously. Okay, and this goes up to the 30,000. So just think like if you have to do it manually, you can never do it manually, in fact, because you can't copy a file onto 30,000 servers and then performs the changing the permissions, setting up the ownerships, or restarting the services, uh, and attaching it behind the load balancers, like things like that automatically on 30,000 server. It's a very huge amount of scale or to operate. So you see that DevOps not only increases the speed, it also helps you to scale out. So you are able to do the deployments on 30,000 servers, and that too so many deployments in every hour. right? So this much amount of deployments requires really a very facilitated, like lot of automation would be required to achieve this scale. Okay. Okay, so you will see that DevOps basically fits into the lean and agile Scrum practices. So it helps to eliminate the unnecessary activities from the lean perspective. I already told you it's like the lean mostly focus on the continuous improvement of your applications, and minimum amount of resource utilization. There shouldn't be the resource wastage of the resource utilizations, and only the optimal and the necessary task should be a part of within the lean. So it eliminates any unnecessary activities which is being required in the lean practices, lean methodology to be implemented. And within the agile, you will see that the response, like all the tasks that we are doing, you are continuously integrating it. The response time of deployment is very short. There are shorter releases cycle. So as soon as you have written up your application or code, you can release it into the production. And the collaboration improves in the agile between the development teams and the operations teams, and as a whole. Okay. So what are the effective pillars of DevOps? So there is a collaboration. We already discussed about the collaboration between the different DevOps stakeholders, between your development teams and the operation teams. And then there is a affinity. So what is the affinity means? Affinity is basically a shared organization goals, uh, so that the learning between the different group of peoples is there. Okay, so this see, whenever we talk about the DevOps basically helps you to solve the issues, okay, for the overall application delivery, right? So it continuously there is a change in the technology and the tools which are being brought. Okay, they are also getting if you are using certain tool, it doesn't mean it's you have learned everything about that tool, because that tool are itself going inside the continuous improvements. Okay, they are also following this DevOps practices of continuous improvement, so they are going to release an upgraded versions shortly, which might be having the additional functionality. So you will have to continuously upgrade yourself for implementing the DevOps practices. Then uh, we have large number of tools to overcome different issues. Okay, and then the scaling is very important in the DevOps to handle because any application out there, the main goal of the application is to scale as much traffic for as much users as they can, right? So scaling, the environments are becoming more dynamic now, and more number of when as the user base grows, your application should be scalable enough, and that's what DevOps provides to you. Okay, you can scale your infrastructure as you require. So let's talk about the lean methodology that we just discussed. So lean basically focus on improving of the overall value and reducing the wastage. This is the main goal of the lean methodology to be implemented. Okay, and uh, if you talk about the lean there, it takes in the user, the end user, that is your customer advice, and you know improve on them, because your end user is your customer only, and he's going to use the services. So it makes sense to take the advice on them, on their requirement, and help improve on them. Okay, and you will see it basically revolves lean basically methodology basically revolves around getting the requirements of the customer, whatever issues that they are facing, they have to resolve it in the shortest period of time. Okay, they, and in an effective way where the value is more and the wastage is less, so that the customers that are interacting with the application are actually benefited from the overall features that you are introducing. Okay, and their issues that they have reported earlier are getting resolved, or their suggestions are getting implemented, so that it will further improve the overall customer satisfaction. So it basically works on maximizing the customer value. And then lean basically works on the five principles. So first is like you have to define a value. There is a stage, like in this stage you will see that it precisely defines the perspective of the end customer identity. So you have to define the overall goal and the value that brings in your organization. So it starts by defining a value. Then you have to map the value stream. That is, you will create a stream to deliver that value continuously in your environment. Okay, and then you will map the overall value stream, and then you will create a flow so that that value stream that you have created is continuously being implemented, and then it would be provided to the customer. Okay, so that the customer can use it, and then you will take feedback from the customer, and you will go on pursuing the perfection to the customer. So it all starts with the requirement, that is defining a value. Then it comes down to the mapping the value stream, that is the way in which this value is going to be implemented. Then there is a flow which is being established so that this value is continuously being provided into the to the customer. Then the customer is going to use it, and then they are going to provide a feedback to it so that you can further improvise on the value that you have initially created. So you will see that it focuses on removing the waste, that is the reducing the tasks which are not required, or removing the products which are not required, and maximize the value, that is the overall customer satisfaction we are talking about. This is what the lean does. And if you will see, there are basically 7 types of waste which lean deals with. So it removes the overproduction, so you don't want to be overproducing a quantity. Okay, so in our case it would be like over automation. So you don't want to do the extreme like over automation. What is being required, you only want to automate the those tasks, not everything needs to be automated. So that kind of over automation you want to avoid. Then there is like transport. Okay, so uh, within the transport, it's like transporting of between the different environments of your application. Okay, and then there is motion, extra processing, waiting, inventory, and defects. This is from the business perspective. Okay, so lean is from the business perspective. See, all these methodologies, if you will see, then they were implemented on the real business ends, and then the IT industries have taken those methodologies and tweaked them and implemented for their software development. Okay, so same practices, these are the types of ways which the lean implements to reduce the waste in your application development. Just a second, my got crash. All right, so here is a DevOps workflow for you. Okay, this will help you to understand the overall DevOps much more, the continuous life cycle that we were talking about till now in a much more effective way. Okay, so it all starts with the business needs. So business usually what happens is the business is going to decide what functionality is required to be built and delivered to the end user. Okay, so it all starts with the product owners and the business needs and the use cases for the business, and they are going to have a discussion with the software development teams, and they are going to relay all the information that the business requires certain products. So let's say if uh, if a business is planning to do a sale like let's say in an e-commerce industry, and then they want to track all the users, they want to send out the notifications and things like that. They are going to communicate this all this requirement to the software development teams, and now the software development teams, okay, they are the ones who are going to analyze all these requirements and decide how they can be built in inside their application. Okay, so uh, that's a part, that's the first step where the requirement is being gathered, and the business will be gathering providing all the requirements to the software development teams. Now the software development teams are going to analyze it and going to code that inside their application, that is create a functionality in the application to be delivered. Okay, and for that they are going to now write the code after the for that functionality to be implemented. So they are going to uh, write the entire code and commit that inside the Git. So what is a Git? Git is basically this is, see, Git is the one of the tools that we are going to discuss. Okay, so from Git you will see that all the part belongs to the DevOps. Okay, so everything DevOps would be taking care of. So you will see that Git helps you to manage the code, that is the files and the folders. It You can create a version. So usually what happens is whenever you are writing the code, okay, it can go very complex. So it's like there are like thousands of files and folders you have to manage, and you can once you start writing your code, you have to change the different files and folders, so it becomes very complex to track what changes you have done. And then you might not want certain changes, and then you remove it to make your code work. Okay, so this can quickly get very complex, and then it's very hard to track which person has made what changes. So there would be like multiple team members in a let's say 10 to 20 individuals working in a team. So it becomes very complex to detect which member has done what changes. Okay, that's another problem. And then there is a collaboration between the 10-20 individuals, like some is working on some module and another person is working on another module. Then they have to combine their code, so they need a centralized some place where they can keep that code, then share that code between themselves and develop from there, right? Because everyone is working. So how do you overcome all of these challenges? So Git can address all of these challenges for you. Okay, you can easily collaborate, okay, between the different individuals using the Git. So Git will help you create the version. First of all, whenever you install the Git and make any changes to the file, Git can automatically detect the changes and show it to you that you have the previous version and the newer version of the file is having these changes. Okay, another thing is, any individual who has done any changes into the file, it can keep a track of those changes and even mark those changes to the users. So if you want to see which person has done what change, you can easily review them through the Git. Another thing is when 10 to 20 people are working in a team and trying to collaborate, then the Git helps you to and it helps you to collaborate between these individuals. Okay, how it is being done we are going to discuss when we discuss the version control management, that is Git. Okay, that's a part of DevOps. So that time we are going to discuss this in more details, but the problems that I just discussed with you, Git helps addressing all of these issues. Okay, and at last you will see that once the this 10-20 individuals working in a software development teams have developed the code and merged their code to work as a single code, because at the end of the day everyone is working as in single organization. So they don't want 10 to 20 repositories of code, they want a single code which is having all the functionality built into it and running as a whole. Okay, so they merge this and deliver it as a software check-in. So that is the Git is working in the backend, and through Git they are able to deliver it the entire code. Now you are going to put that code into one location that we are going to say a branch. For now you don't really need to know what the branch is, just think like you are basically targeting it as a place where the finalized code is there, because there would be large number of versions. Okay, so people are going to continuously write the code and push it, so you need to know when the entire code base has been completed, Okay, so at that point you are going to move it inside a production branch, and that production branch always denotes the finalized code. Okay, that is the complete code which is required for the application to build. Okay, that is what we are referring to as software check-in. And Sridhar, I will come back to your question shortly. Okay, and then once this software check-in has been done, okay, then once we have this production branch ready, which is having the latest code implemented from the software development teams, then the Jenkins, that is our continuous integration and continuous deployment tool. Okay, so we are going to perform all the builds, releases, continuous integration, continuous deployment, everything from the Jenkins. Jenkins is an open source tool. Okay, and this is the most famous tool out there for CI/CD perspective. It integrates, it's having huge number of plugins. You can change the functionality of Jenkins as in the way you require. Jenkins has lot many plugins. It can integrate with the other tools. It can run your test cases or create reports, everything. Okay, so we are going to discuss that when we talk about Jenkins. Okay, so once you have done the software check-in, you are going Jenkins is going to pull that from the repository. Okay, or you can even trigger the Jenkins. That's a separate thing we are going to discuss when we come down to the Jenkins. And then Jenkins will download this code onto the Jenkins server and initiate a build. Now, what is a build? So once the code has been downloaded, that's in a human readable format. That is something which you are able to read in a programmatic language. Okay, it can be any of the programmatic language. It doesn't like your Python, Golang, Node.js, Java. Okay, that can be any of the programming language that you have written your code in. Okay, Jenkins can download it automatically from that remote location onto the Jenkins server and then initiate a build. So once the code has been downloaded, it's going to compile the code. Now, what's the compiling of the code means? If you talk about Java, okay, so in Java, it changes the code that has been initially being written into a bytecode. What is a bytecode? Bytecode is basically a combination of 0 and 1s, which is understood by the JVM, that is your Java virtual machines, which is required to run the Java code. So it will convert it into a format which the computer understands. So it's going to convert that into the bytecode, and then you are going to deploy it over in the JVM, and that's how the Java code runs in the same way, whether you are running it on the Linux machine or the Windows machine or any of the operating system. Okay, it appears to be same. So you will initiate, once you have initiated the build, it will download all the libraries and the dependencies which are required by your code to work from the external repositories, and going to create a finalized package. So like, what would be a finalized package? It can be your war file. A war file is like a web archive. So if you are running a website, so you will create a war file or a jar file. Okay, and that we basically call an artifact. So whenever you run a build in Jenkins, that's going to result in an artifact, and we are going to cover the like these artifacts once you have generated. Okay, these needs to be deployed on the production servers, like in your Tomcat, okay, application server, for them to run. Now, before once you have initiated the build, then before deploying, you need to run the tests, that is, do the testing on this before you are able to deploy it on the server. The testing will ensure that the code is working in the way it should work. Okay, it's delivering the functionality which it should do. Another thing is, uh, if your so how the test cases are getting triggered. So once the build has been completed, Jenkins is going to trigger the test cases. Now there are different types of testing which is being performed. Okay, so there is like unit code testing. So unit testing is basically implemented by the developers. Okay, so whatever code that they are writing, they are going to write the unit test cases for that. And that unit test cases is going to test the code, like let's say if you are doing an addition of two numbers, just for an example. So you can write a test case where you are feeding two numbers and you already know the result and then matching the result with it, like that. Obviously it would be much more complex on the application side, but that's just for your understanding of how you can write the test cases. Okay, and once you have written the test cases and executed, Jenkins can execute the test cases for you. Once you have executed the test cases, then there is a then you can perform the regression testing, code coverage, like the test cases that you have written, how much code is being called. So you can use something like a cobertura in case of Node.js, which will automatically mark the lines with 0 and 1s to show you how much code is getting covered by the unit test cases that the developers have written. Now, based on that code coverage, you can tell your developers that this much code is covering and this much code is remaining, has not been covered by the unit test cases. So you should write your more test cases so that the entire code base is getting covered. Okay, that will help you to create and test the changes, like the failures in your code before it actually affects your production. Okay, now once you have now normally this test cases is written by the developers, and if we talk about the regression testing and all the other kind of testing, that is being done by the QA team or your testing team in your organization. Okay, and they are going to work with you because it's a collaboration approach, so you are going to work closely with them and trigger those test cases, regression testing, and all those kind of test cases that they have written to uh, after the build has been done. Okay, now if you can put on the certain conditions, like if 90% or 95% of test cases are getting pass, okay, then you are good to go ahead with the deployment. If that value is less than 95%, then you are going to mark the build as a failure. Okay, in which case the developers would be notified that the build has failed, and they will have to resolve the issues which was into the testing, reported by the testing. And once they are able to resolve the issues, then only they can move ahead with the build. Okay, like that. So those are the this is how the testing is being done using the Jenkins. Now once the testing has been done and you need to deploy, see, you have to deploy at this point in time, you have to deploy the on large number of servers. Let's say you have to deploy on 10,000 servers, like in the case of Amazon. So how do you deploy on 10,000 servers? You are not going to copy a artifact onto 1,000 servers manually one at a time. That would be very time consuming. Okay, so how do you automate this? For that, we are going to learn the Chef, Puppet, Ansible, and Salt. These are the four tools, okay, that we are going to learn for the automated deployments. And another thing is you can also use the Jenkins built-in pipelines. Okay, that can also do the deployment for you. And thirdly, if you are deploying into the Kubernetes, we are also going to cover that, how you can directly deploy your containers. If you are using the containers, then you can directly deploy those containers into the Kubernetes environment. That we are also going to cover, okay, when we discuss the Jenkins. So then you run this automated deployments. It's going to deploy your artifacts onto the servers which are running, and once and take all the necessary steps. So there are steps like you have to deploy this in the web apps folder and then change the ownership permissions and then restart the Tomcat. Now you can't restart the Tomcat like that because your users are accessing your web application and mobile application, so that will go down. So then how do you deploy it? Okay, So for that, we are going to discuss the blue-green deployment, rolling deployment, and the soft link methodology, which you can use to do the deployments. In which case, okay, the users are not going to see any downtime. Okay, that's a part for the automated deployments of how we are going to perform the automated deployments. Now, once the artifact has been deployed on the server, services have been restarted, and it becomes available for the end user to use. Okay, then you have to make sure the effective monitoring is there and everything is getting monitored. Okay, like your all the aspects of the infrastructure, your uh, uh, matrices that is being collected, so all of those, like your application as a whole, so every part of the application is getting monitored. Okay, that's from the monitoring perspective. And after monitoring, then again some other use case will come and it will form this closed loop. Okay, that's what the continuous delivery cycle means. Okay, so DevOps can create this in an automated way. After the software development teams has committed everything, rest of all the steps can be automated using the DevOps, which takes significant amount of time. Okay, and that's a continuous delivery, not a continuous deployment. We are going to see the difference between a continuous delivery and a continuous deployment shortly. Okay, all right, so let's take on the questions now. I see quite a lot of questions. Okay, all right, so Sridhar has a question. Can't we use TFS or source control to achieve DevOps? Okay, so Sridhar, Git is just an option for you. It's a distributed version control system. Okay, and the main thing with the Git is that it's open source, and it has been developed by the Linus Torvald, so it's really being used on scale. While the TFS is developed by the IBM systems. Okay, and so you can use any of the source control. It's not necessarily a Git, okay, that you have to use. We are covering the Git because it's most widely used as compared to TFS. Okay, that's why we are talking about the Git here. But surely, if you know TFS, you can use the TFS for the same purpose. No need to use the Git. Okay. GitLab Soham is a different thing. I will talk about that shortly. Okay. Git is different and GitLab is different. So I hope that answers your Sridhar question. Okay. So you can use the TFS, but since Git is more famous, that's why we are using the Git. All right. Then we have a question from Vivek. Vivek is asking, are we going to implement this structure in hands-on? Yes, Vivek, we are going to implement this, okay, in our lab. So at that time we are going to create a pipeline. So you will see that each of the steps is working as a pipeline, how much time it takes, uh, what are the logs being generated for each of the stage. Okay, and then all the stages, everything would be covered in the lab session. Okay, then Bala Subramaniam is having a question. Automated scripts for newly developed code or regression scripts for holistic scripts includes both progression and regression of the application. Okay, Bala, the thing is, you can run, or there are like, when I talk about the testing, there is like huge amount of tests, different types of testing that is being performed on an application to determine the issues with the builds. Okay, like with the newer code, so you can have the regression code testing or progression testing or all of this, which you have said, but this is mostly done by the QA team. So as an DevOps team, you are just going to trigger what they have written. As in DevOps, you are never going to write the test cases. Okay, that's a work for the QA or testing team. Okay, our main work is to incompensate what they have written for testing into the build and release. Okay, that's why we said that DevOps works on the collaboration. Okay, although it's being written by the QA team, DevOps is going to help in automate and build it as a single process. Okay, so how they achieve this depends upon the testing and the QA team only. Okay, and though you can work with them, help them improvise on it. Okay, make them aware about your system, how you are going to trigger, take inputs from them, provide your inputs, things like that on the collaboration basis. But this is something which is being done by the testing team. So we as in DevOps, we don't really focus on that part that will be built by the QA team, although there are tools and everything that we are going to facilitate. But then this would be in collaboration with them. Okay, all right, then Sanjay is having the question. Yeah, Nikunja, so you can run all of these test cases like unit test cases, functional test cases, system test cases, regression testing. So all of this type of testing you can perform, and all of this should be automated. So usually you will see that testing teams use the Selenium. Okay, that really helps you to automate the testing from that perspective, where it can even click on the browser's elements, log in, verify that everything is working fine, and it can do it repeatedly, because we are saying that we want to run the shorter cycles for releases. So that kind of automated testing will help in improvising the overall delivery of the application. Okay, okay, and after just a second. Okay, so Sanjay is having another question. Once issue has been resolved, do we start from point 3 and follow all remaining phases? Yes. So Sanjay, once this has been resolved, see, this is already automated. Okay, so you will continuously monitor the system is working overall. Okay, and development teams, it's because it's automated. Okay, so they are going to work on the next set of requirements, then going to merge it, and then this pipelines continuously works as a whole. And once you have established this pipeline, you will work on improving it. Okay, when I say improving it, there are many more things which you can include in this pipelines, like there is a code quality which you can improvise using the Sonar Cube. Okay, tools like that. So you keep on integrating and improvising this. If something fails, then you help in troubleshooting, but the main goal is to create this with the least human intervention. Okay, so everything will work. And then uh, once yes, so after the development teams have done their coding, they will continuously use it, right? So they will again go back to the point 3, again deploy a code, again run the builds and things like that. So they are continuously going to do it. Okay, all right. Next comes for the Prasad. Do we get to learn real-time issues, rollbacks, and resolution method scenarios? Yes, Prasad. So I will going to show you see. I will show you how the deployments are being done. Issues is something which you might or might not get into. Okay, but if you are we can discuss some of the issues which are very common, which we have seen. Okay, I will share that with you. Okay, uh, and then rollbacks, we are going to discuss how we can perform the rollbacks. Okay, there are strategies for the rollbacks as well, and resolution is obviously depending upon the issue, right? So I'm going to share that the issues that I have mostly seen, that's from the experience point of view. Okay, but obviously it's not possible to mimic the issues, right? Vishal, I'm just going to shortly answer that question. Okay, all right. Then Janesh is having a question. So Git is managed by dev team or DevOps team? I mean, dev team must be doing check-in of the code. Yes. So Ganesh, Git is used by both dev team and DevOps team. Although you will see the overall administration of the Git and the repositories for the Git, like your GitLab, okay, or GitHub or Bitbucket, those are being managed by the DevOps team. Okay, and you can work in collaboration to find out the better ways of running your builds, like what strategy of branching you want to follow and things like that. We are going to discuss them when we discuss on the Git, but as an on the administration part, DevOps is going to maintain it, but it's going to be used by the development teams and the DevOps team both. Okay. Okay, then Nitya is having a question. Is VSTS, Azure, DevOps, and Jenkins are similar? Yes, Niteshri, everything is similar. When we talk about DevOps, Jenkins, see, whatever we are going to cover, it's exactly the same. Only in this case, the cloud provider is changing. That is Azure. So you are going to use the Azure-based services mostly. That's it. But if we talk about the overall goals, see, even if we talk about the any of these cloud provider offerings, in the base you will see that they have used this while the Jenkins is open source, they have created their own version of Jenkins, okay, for the build and release, and that's how they are facilitating it on their system. It's not different, it's exactly the same. So you, if you even know Jenkins, you can run Jenkins in their cloud and you can perform the build and releases there. So Jenkins can be run in data center, in any of the cloud providers, in Kubernetes kind of deployments. Okay, so it's a one tool which you can run anywhere, while if we talk about the Azure, you can't run it on AWS and on premise like that. Those kind of limitations are not there in Jenkins. Okay. All right. Another question from Niteshri. We have artifacts, builds, and release pipelines over there as well, along with CI in VSTS Azure DevOps. So as I told you, like all the artifacts, build and release, this is a part of the CI, right? So this would you. There are many more. Like if you talk about Bamboo, okay, then if we talk about AWS Code Deploy, okay. So there are many tools out there. What we are covering is the most famous ones, open source, and things which are continuously getting improved, right? So you would see that the Azure did came later. Even before Azure, the Jenkins was used for the build and deployment. So you will find that many organizations out there uh, is using Jenkins. Another thing is Jenkins is very flexible in the sort of way that it provides the plugins for the functionality, extending functionalities. Another thing is it easily integrates with configuration management tools. Then you can write your own scripts, you can write in any of the programming languages that you want. So it has all the available options. Okay. And it's not depending upon just one option, so you can write and run it as in the way as you like. Okay, so you don't create a dependency. See, whenever we talk about any of the cloud providers, if you use their application, it becomes a closed environment. That is, you become too much dependent on that cloud provider. So let's talk about, let's say if we are running on Jenkins on instead of Jenkins we are using the Azure. Okay, then that functionality, and tomorrow we plan to move on AWS, so we won't be able to move on the AWS because that is we are using an Azure based CI tool, right? So we can only run in Azure, and we don't want to create that type of dependency. So it's always good to use the tools which are any cloud or like any cloud provider free and can run anywhere in any of the cloud. So if you are having using the Jenkins, then you can create Jenkins in another cloud and start using there as well. Okay, that's the advantage. All right, next question is Bala is having. Thanks for the explanation. To certify a new code to production as a DevOps team, how do we ensure the defect-free code is released to production as part of DevOps pipeline? Okay, so Bala, the thing is, the for us the defect-free code is the one which has passed the testing which has been written by the QA team. Okay, so you can put on the different tools like SonarQube I talked about. Then I also talked about the Cobertura. Okay, then we also talked about the unit code testing, functional testing, and all of these testing. Then we talked about the Selenium, right? So if you are able to run and you know all of this testing, it should report you for the defects. If it's not resulting in any of the defects, see, you are not going to write the test cases. You are going to create a system which can run it in an automated way at the time when the build is run, right? So if everything is getting passed, it means it's defect free. Okay, and it's up to the QA team to write the test cases. If there is some defect, they should identify it. Okay, all right. Nikunja has a question. Container which phase we will implement. So I will show you how you can see. We are containers mostly support the microservices kind of architecture. Okay, it has been built for that, for the seamless scaling. Okay, you can run the monolithic, but best suitable way is to run the microservices. So when we talk about the containers, I will show you for an e-commerce application how you can deploy different microservices within a matter of few minutes. Like when there is nothing, how you can create everything from the scratch to run. Okay, and I will also show you how you can do the build and deployments in case of containers. So we are going to cover all of those parts. Okay, and it is having the blue green deployments automatically built in inside the Kubernetes. Then Kubernetes can run in your cloud as well as your data center. On your laptop it can run anywhere, right? So that's an additional advantage. We are going to cover the neutral softwares mostly, so that we are not dependent on someone. Okay, and we can run it anywhere. Okay, so Vishal is having a question. What happens if the code fails in production in this model? Who gives more attention here? Application specialists or developers? Who takes care for the call of rollbacks? Okay, now Vishal, that's an good question. Okay, because that's certainly the case. If we are promoting the speed and doing much more frequent builds, then this can result into the code failures. Now it's important to understand how this is being handled. So whenever the failures are resulted, if your QA team is able to detect it, okay, much more faster, okay, then it will automatically be detected by the QA. And if they don't pass the test cases, okay, then you are not going to move ahead with the deployment and mark that build as a failure. Okay, at that point that build is going to be reverted to the developer and they will have to fix it. That's a one way. But let's say somehow it was passing the test cases, but the code was failing from the infrastructure point of view, that it was missing on some firewall rules or something like that. It was not able to connect to the DB, and your after deployment it having a wrong endpoint, so it was not able to connect and failing on the production systems. That kind of failure, okay, won't be detected on the testing phase. Why? Because here the issue is that the DB endpoint was wrong. That is, the DB server we were querying was wrong, so it was not able to find it. So in that case, what we are going to do is we are having the health checks associated with the application. So whenever we do the newer deployments, we create an another stack of application. That is, one model of application is already running. That is, the version 1 is running. We are creating a version 2 of application. So we will create an entire infrastructure to run that version 2. Now that version 2 starts to fail, see, version 1 is already running in the production right now, we haven't changed, and version 2 once deployed, its health check that we have associated, there are two types of health check. One is the infrastructure health check, second one is the application health check. So if the health checks are failing, okay, then it will never come into the production. Okay, there would never be a shift from the v1 to v2. Okay, but let's say somehow this is also passed. Okay, and health checks also got passed, but still there is some failure resulted. Then you are having the two infrastructure right now. Here is there are two infrastructure. I talked about the blue green deployment strategy, right? So there is v1 and v2. Okay, now you can switch to v2, and after that it resulted in the failures. So our automated system would be able to detect these failures. Okay, and it will provide you with both the ways. You can either, if it detects the higher number of failures on the load balancer, it's automatically going to revert back to the previous build, or you can do it manually as well. Okay, in case your systems are not picking that up. So both the type of failures are being handled. Now in case of EC2, there is if you are just doing a build, not, let's not talk about the containers now. Let's say you are doing on EC2 and your build fails, and if it has to be reverted back manually, like somehow everything is getting passed, everything is working, but a higher number of errors are being reported, that's a failure of the build. Okay, where neither the test cases were able to detect, neither the health checks were able to detect, neither nothing. Only we are seeing it, in the ELBs, like there is the 5xx error has gone high. Then in that case, you can automate something like the builds would be deleted from the artifactory latest build, and the older build which was there would automatically be deployed. Okay, that would resolve the issue because the last build was working fine. Okay, so that would run, and it will always see anything which is going wrong in the production would always be the call of the DevOps. Okay, so you as a whole will always be responsible for that. Mostly this kind of functionality is built in inside the system. Okay, this is not something which is being left alone. So developers is going to, or DevOps is going to take a call on that, and their system is going to handle that kind of rollbacks. I hope that's clear to you now. It will become more clear to you when we discuss the Jenkins. Okay, that was just an introduction. All right, so Pratik is asking what is the difference between Jenkins and Bamboo. See, Pratik, the Jenkins is it's a kind of an approach. Like Bamboo is a paid version of, okay, of the CI. Now both are doing the same thing. Okay, so it's just a matter of choice between the two parallel products. Okay, whether you are using Jenkins, whether you are using Bamboo. There is no such thing which Jenkins can do and Bamboo can't do, and there is no such thing like which Bamboo can do and Jenkins can't do. Okay, just that Jenkins is open source, Bamboo is a paid one. Okay, though you can get the Jenkins support from external companies out there. Okay, so that kind of limitation is also resolved in case of Jenkins. So depending upon this difference, rest all the things can be done by both the tools, so there is no limitation like that. Okay, all right, so Som is having a question, like also we are going to do Ant and Maven as well, or else no use of Jenkins practically from DevOps point of view. Som, it's not that it's not having a from the DevOps point of view. We are not going to cover the Ant. Ant is an old one. Okay, It's not being used anymore. Only the legacy kind of projects are using it. We are going to cover the Maven, okay, and then there is Gradle as well. So we are going to cover the Maven, and we are going to understand the Maven projects. So the build and release and the labs session that I show you will be having a Maven project only, okay. So we are covering the Maven, okay. Mm, Soham, I hope the course, like the overall course guideline for the DevOps Plus is with you. Okay, we are not covering any other scripting. We are going to cover all the topics which are related from the DevOps perspective. Okay, and if you want any additional scripting, you can get in touch with the Cognitia support team. They will help you out with that. Okay. All right. Anyone else having any other question? All right. So tomorrow we are going to finish with the introduction, and we are going to take the virtualization as well, virtualization and the vagrant. So Nikunja is having a question. Will we be covering AWS? No, Nikunja, we are not covering the AWS in DevOps. Okay. Uh, though I don't think we are covering, we are having any of the topics is from the AWS. You can get in touch with the support team, Cognition support team. They will help you out with the, if you want, if you have want some more clarity or want some additional topics in the trainings. Do we need to install any of the DevOps tool before tomorrow class? No, Bala. You don't have to absolutely install anything previously. Whatever lab sessions that we are going to do, we are going to start from the scratch. That is, we are just going to have what we call our laptop, not even a VM machine, okay. And then we are going to eventually build up everything, okay. That will help everyone to replicate it, okay. All right, so Janesh, and the entire course content is enough to switch to as a DevOps resource. Yes, Janesh, exactly. The entire course content which we are having is more than enough. Okay, not only DevOps, it's an advanced DevOps course. Okay, so everything related from container deployment to orchestration tools, we are covering everything from the scratch. Okay, so that should that's more than enough to work as a DevOps resource. All right, that's all, everyone. If anyone is having any other issues, do let me know. Otherwise, that's all for today's session. I'm going to see you in tomorrow's session. Okay, most probably we will cover the theory part by tomorrow, and then in the third session we are going to take on the practical. Okay. Okay, Nupur, for the DevOps interview questions, you can reach out to the support team. They will help you provide with all of those questions and those kind of things. I'm mostly going to focus on getting you through all the technologies, tools, and everything that is being required by the DevOps and the practicals, okay, from the lab perspective. Interview questions, support team can help you with, okay. Thanks, Sujit. Thanks everyone for attending today's session. Okay. You will receive a feedback form. You can share your feedbacks with us. Okay. And that will help us continuously improve our sessions. I hope I have answered all your questions. I would really, it would really be good if you can raise all your queries, raise as much queries as you have. Okay. I will answer all your queries. So Vishal is having one question. Any real-time examples from your professional experiences about any challenges faced with the DevOps deployments? Yes, Vishal, I'm going to share you. See, once we reach down to the Jenkins, I will share you what challenges will you get, where you have to decide, take a decision, and then what type of decisions can you take, all the choices that you are having. Okay. So we are each and every tool that I'm going to discuss, I will share my real experiences with you. Okay. All right. Thanks everyone. I'm going to end the session now. We'll see you tomorrow at same time.